Welcome to VB2020 Day 3. I'm Angela Lamont, and I have to say, if you missed Day 1 and 2, well, there's absolutely no problem at all, because you can rewatch anything you like at this conference. If you have a look on the left-hand menu, you will see Watch Live, and you can go and choose Day 1 or Day 2. Although as we've just started live Day 3, you might as well stick with us for now. There's also some on-demand presentations that you can catch up with whenever you like as well. And there's the Threat Intelligence Practitioners Summit, brought to you by the Cyber Threat Alliance. But of course, here we're staying live with 7 presentations recorded, but with live Q&As. So stick with us and enjoy VB 2020 Day 3. There's also some chat, so feel free to chat to our partners, the rest of the people watching, the delegates, your colleagues, all in the chat. And again, on the left-hand menu, it leads you to the chat. Or if you haven't got the left-hand menu, look up at the top right and click the tab, and the menu will drop down from there. So we've got the general chat, which is fantastic. They're all getting very excited about Day 3 in there. And Mark, I am loving your VB 2020 t-shirt. You know, you could have a good market there. That's fantastic. I have to say, I am a complete newbie to the Virus Bulletin conference. And everybody's been so kind to me in the chat. So if you're a complete newbie as well, hop in the chat. You never know who you might meet, but it's a lot of fun in there. There's also a Q&A chat section, and you can ask questions of any of our speakers. But if you want to ask a question in the live Q&A of a speaker that's talking at the time, please mark your question with hashtag #AskNow, and we will fish that question out quickly, and I will put it to our speakers. There's also a help desk chat. So if you have any problems with using the interface, or you want to ask a question that hasn't been answered elsewhere, just hop into the help desk and someone will help you out. Now, over the last couple of days, I've had quite a few comments about this beautiful item here. And excitingly, it is now time for mug auction. Mugtion. It's time for the Mugtion. Yes, you could own this beautiful object of desire and help the planet via the World Land Trust. But actually, I don't know why I'm telling you all this when we have a professionally made film to do it.
Do you love hot beverages? Do you love trees? Then we have the perfect solution for you. Head to the Mugtion at www.giveawayallyourmoney.com. Your bid could help you enjoy a lifetime of hot beverages in this utterly unique and ridiculously awesome VB 2020 mug. You'll never see another mug like it, and it will help to protect trees. Not this actual tree, but thousands of acres of trees in Ecuador's Choco Forest, helping to preserve an important ecosystem and the endangered species within. So, don't be a mug. Bid now in the Mugtion. Enjoy hot beverages, save trees, enjoy your utterly unique mug. Really, what's not to like?
Quality programming here. So dive into the brand new chat thread we've set up, the Mugtion. Place your bids and get bidding now. We're not going to give you that long. We're going to close the bidding at 1900 UTC, and we'll announce the winning bidder later in the show. All the rules for winning this beautiful item, or rather bidding for this beautiful item, are in the chat thread, which has now magically appeared on Discord. So now it's time to introduce our first speakers. And our first presentation is Graphology of an Exploit, hunting for exploits by looking for the author's fingerprints. And that's Eichel Itkin and Itai Cohen.
Hello everybody. Today we are going to present a research we made in recent months in which we built a profile of one of the most active exploit developers for Windows. we are going to show how we were able to track down 11 of their exploits for the Windows kernel, and many of which were 0-day at the time of development. So just before we start, let us give you a brief info about who we are. My name is Itai Cohen. I'm a malware researcher and a reverse engineer at Checkpoint Research. I'm also one of the maintainers of the open source reverse engineering framework Radar 2 and the maintainer of Cutter. With me today, my friend and colleague Eyal Itkin. Eyal is a vulnerability researcher at Checkpoint Research as well. So, just like many other good stories, our story began with an incident response case. The incident response team in Checkpoint reached out to us with an interesting and a complicated attack against a client. And in this attack, we noticed one specific binary that caught our interest. It was a very small 64-bit PE file that looked suspicious. It contained unusual debug strings that suggested that we are looking at an attempt to exploit an LPE vulnerability. It also had a PDB path inside it that did not leave a lot of place for imagination regarding what this file is, as it stated very clearly that this is VB2020 859. So we quickly reverse engineered the binary. It was pretty straightforward. The vulnerability was a use after free in Create Windows X, and it was used to elevate the privileges of the parent process to system. And this is not the first time that we see an attack utilizing an exploit, and the leftover strings and the PDB path made us believe that we are looking at yet another script kiddie that downloaded an implementation of the exploit from GitHub or some other public resource. But as we quickly found out, this was not the case. We simply could not find any public resource of this specific implementation, not on GitHub and not anywhere else we looked for. The implementation was completely unique. Also, we noticed something interesting. The exploit itself was probably not written by the developers of the malware in the attack. And we have several things that suggested that this is the case. The first one is that there was difference in quality of the code. With all due respect to the malware in the attack, the exploit was simply better written. The separation to functions, the check for versions, and other things suggested that it was written by another person. Next, while the malware and its modules were all obfuscated, the binary of the exploit was not, and it was very clear for us as reverse engineers to see what was going on in there. Also, the timestamps of the binary were different. The exploit was compiled before the malware, and I'm not talking about single day differences, but something more meaningful. And the PDB paths were different, suggesting that the binaries were compiled on different machines. So take all this, add it to the fact that the small exploit was in a separated binary, and we can guess that we are talking about different developers here. And this was the starting point of our research. And to understand why it is meaningful, we need to understand the basics of acquiring and embedding exploits in malware. So usually we tend to look at malware as one complete software, sometimes with modules, sometimes not, and we treat this software as it was written by a single person, a team, or a group. But the truth is that writing an advanced malware, either by nation states or criminals, involves different people with various skills. So say if you're an operational entity and you want to use an exploit, you cannot rely on your malware developers alone. Finding a vulnerability, reliably exploiting it, and all these most probably should be done by specific teams or individuals who specialize in this particular role of exploit development. And if we are talking about the malware developers, on their part, they don't really care how it works behind the scenes. They just want to know the API, this integration point that they can use to integrate the exploits in the malware. Now, there are multiple ways that malware developers can acquire an exploit. And if we are speaking of big organization here, they can get the exploits from a team in their organization. And they can also get the exploits from a team in another organization, if we are talking about collaboration between multiple intelligence agencies, for example. They can purchase the exploit from quote-unquote legal entities, such as offensive cyber companies or exploit brokers. And of course, they can buy the exploit from users on underground forums, or maybe the most accessible and the most popular way that we see nowadays is to simply download the exploit from GitHub or other public sources. And now we'll move to the next part, in which Eyal will show how we were able to extract and fingerprint unique characteristics of the exploit developer behind the exploit we found, and how we hunted for these characteristics and found many other exploits written by the same developer.
Thank you, Itai. And if you want to focus on the exploit themselves, then we need to think like an exploit writer. And the most important rule to remember is that our exploit is our product. This isn't some script of proof of concept that we upload to GitHub and forget about. This is the product that the client actually paid for. And the client wants us to support as many versions as possible. We need to support both 32 bits and 64 bits targets, as well as many Windows versions as possible, ranging from Windows XP and Vista and up to Windows 10. And since we need to support so many Windows versions, we will need some way to fingerprint the exact version used by our target and calibrate our exploit accordingly. In addition, we'll most probably need some direct access to a given syscall somewhere along our exploit, meaning we will need an additional syscall gate, most probably written in assembly, and the precise syscall numbers used per operating system version. And the parts that I just described are actually exploit agnostic. We will need them in many exploits out there, and we can implement them as utilities to be used in some sort of an exploit template over and over in all of our exploits. And this is the key point in our research. We are going to hunt down for the author's exploit template and match it. So, what are we looking for? Well, we're looking for the usual suspects. We have unique artifacts, such as hard-coded values, strings, PDB paths, as well as author-specific code snippets, inline assembly, syscall wrappers, everything we could use in order to hunt down for more exploits. However, assuming we have an initial exploit, we will also want to attribute it. So we have the framework, configuration used per exploit, the code structure, or even the API between the exploit and the malware. We also have more exploit-specific artifacts as favorite infoleak primitive used from the kernel to the user, a way to elevate the target process from normal privileges to system, and so on and so forth. Now that we know what we're looking for, it's time to recall that we have a 64-bit sample and we can search for artifacts in it, which we did. And eventually we found a basic artifact and we started a basic search with it, which is a shot in the dark. You can never know if you found a popular code snippet from GitHub or an exploit tutorial, or if you found an actual artifact of the author. And to our surprise, it worked. We found a matching 32-bit sample of the same exploit. And now we have both the 32-bit sample and the 64-bit sample of our exploit, which is great. Using these two samples, we can compare them and check if our author has a single exploit template for both of the versions using ifdefs in the matching places, or if they have two templates, one for 32 bits and the other for 64. Since the rule worked, we started an excessive hunt, which was basically based on this rule, and meanwhile we kept looking on for more rules we could use. One day later, we got the result, and we couldn't believe what we actually found. We found 949 different samples just from the initial hunt. So we found multiple malware families across various years, and it looks like the real thing. We found a lot of exploits of our author. It's time to dig in. Before we could identify the author, we will need to identify the vulnerabilities that were exploited and hope that one of them was already attributed to our author or to a known author we could identify with. Identifying the vulnerabilities themselves was a tedious task because it took quite a lot of time per exploit. And if the vulnerability was exploited as a zero-day, it's usually easy. It's usually well documented in security reports detailing the exact time ID used, unique constants, the flow of the exploit, and so on and so forth. However, if the vulnerability was exploited as a one-day, it's a totally different story. We usually get nothing. We just need to revert to old reverse engineering, patch testing, and testing in different setups to see in which patch use day was the vulnerability fixed. However, sometimes we do get lucky, and we have the CVE ID in a plain strings or in a PDB path, but we can't really count on that because most of the times we won't have such strings, and sometimes it turns out that the strings are wrong for some reason. We found the following CVE ID in one of the samples, but the sample didn't exploit this vulnerability. So we don't really know what we found, why we found this CVE ID, but that's life. In some of the exploits, we found that vulnerabilities were probably located from patch diffing Microsoft fix, meaning we don't have any clear documentation on the vulnerability and no clear mapping between the CVE IDs of that patch and the vulnerabilities that were fixed. So we had to manually go over all of the list and find the most suitable CVE ID for the vulnerability, in which case we attributed to the following CVE. Now that we found all of the vulnerabilities, it's time to present our author. Our author is Volodymyr or Volodya, also known as BuggyCorp, as previously discovered and talked about by Kaspersky. Our author develops exploits since 2015, at least to our knowledge, and includes a list of respectable known clients, such as Turla or Fin8, and even Guncog. Volodya exploits both 1 days and 0 days, and we are focusing on Windows local privilege escalation vulnerabilities because this is the exploit template we started with and hunted for. We were able to track down 6 different 1 days, you can see on the list here, and an additional list of 5 different 0 days, bringing to a total of more than 10 different vulnerabilities that were exploited and solved, which is quite impressive. Before we could identify the fingerprints, we need to remember that we can't simply pick an arbitrary code line and say, well, this is an artifact, because it could be a well-known code snippet from an exploit tutorial or from GitHub. We can't really know. So we need some way of having a control group to compare against and cancel out false positives. Our goal is to show that each exploit writer is unique, meaning that had multiple implementation or exploitation decisions to make. Each decision was a real one, indeed faced multiple options, and was consistent once chose a given decision. And this means that the set of decisions made by the author could comprise a unique fingerprint of the author, and we could use this fingerprint in order to hunt down for more exploits or attribute them to our author. In order to do that, we reiterated the research method on REvil, which embeds a 1-day exploit for the following vulnerability. And once again, a research technique worked. So our control group is Playbit, also known as Laxo 2008. We found it to develop exploits since 2013, and known clients include REvil and Lockcrypt and other crimeware. Playbit only exploits 1 days, at least to our knowledge, and we were able to find the list of the following 5 1 days that were exploited and sold. Now that we have all of the lists settled up, it's time to focus on the author's fingerprints. The first clue we have is a call to sleep. It turns out that most of the exploits start with a call to sleep 200 millis. We're not sure exactly why it's there, but it is a distinct feature. You can't argue about that. At a certain point on our research, when we found a new exploit, we went to the beginning of the exploit and looked for a call to sleep. If we found sleep, we knew it's a Volodya sample, and then we looked for more artifacts just to be sure. So we start with a sleep. The second clue is OS fingerprinting. The goal of this phase in the exploit is to query for the major and minor version number of the operating system in order to check if the target is vulnerable and to calibrate our exploit accordingly. And it turns out that Volodya's favorite method is directly parsing both of the values from NTDLL's image and the headers, as we can see here in the code snippet. We couldn't find this technique used anywhere else, not in Playbit exploits, not in exploit tutorials or in GitHub. So we found it to be quite unique to Volodya, and it uses this technique in most of the samples that we found. And the last technique for these slides, more techniques will be found on our white paper, is the token swap. In order to elevate the target process according to the process ID, we will need the system's token, and we will want our process to point at it. The favorite method in order to do that is scanning the process list. known as PSList. We will use an arbitrary read and arbitrary write exploit primitives from user mode in order to access and read and write memory into the kernel. We achieve these exploit primitives using our initial vulnerability. Using these primitives, we traverse the process list and search for the e-processes of both of our target process and system, and we update our target's e-process in order to point at the system's token. Since the token is a ref-counted object and we just added an additional reference, there is some delicate ref count handling we will need to do in order to avoid a blue screen when the target process exits. And the token is an xFastRef object, which means that the lower pointer bits are actually used as a ref count. If we want to access the actual address of the token, we need to mask them out. In addition, the object header is stored before the token, and once again, it holds an additional reference count. Since Volodia wants to update the reference count in the object header, the steps are mask out the bits of the token, subtract 18, read the value, increment it, and store it back. However, on 32 bits, we found the following bug, which meant that the alignment mask in the read operation is an alignment to 8, but the mask in order to write again the value is a different mask. It's an alignment to 16. So if the token is aligned to 8 bits, but not to 16 bits, we will read the value, but write it to a different address, meaning essentially this is a bug. So we couldn't find it on 64 bits, but it was quite consistent on all of the 32 bits samples. So both the token swap are quite indicative, but the bug is a clear clue that we're talking about a Volodia exploit. Back to you, Itai.
So as you understand, we had the opportunity to analyze many samples and exploits written by Volodia from 2015 to 2019. And while analyzing these samples, these 11 exploits, we noticed a learning curve in Volodia's skills and behavior. So just before we are going to explain this learning curve, we want to mention that it was clear from the start that Volodia was already quite professional from the first exploit we saw them implementing, the CVE 2015-2546, the earliest exploit we were able to attribute to Volodia. Now, the first thing we want to talk about is how Volodia moved from selling source code to selling compiled binaries to their clients. And we have some evidence to suggest it. First, the code of the exploit was properly embedded in the binary. We did not see any weird patching in there. It looks like the malware author simply placed the exploit in the source code of the malware, and the flow between the malware and the exploit was very smooth. Second, a source level obfuscation was applied both to the malware and to the exploit. And that means that the obfuscation was executed on the source code of the exploit. And this also means that whoever wrote the malware and executed the obfuscation had access to the source code of the exploit itself. And last, the exploit elevated the privileges of the current process and not of the parent process, as we saw earlier. Later, we believe that Volodia started to sell the customers compiled binaries. So unlike before, now the exploits were usually shown as a separated binaries and not part of the malware itself. They also contained hard-coded prints with instruction to the customers describing each step the exploit does. So if the customer had the source code itself, they would probably remove those prints. And last, the elevation of privileges was for the parent process and not for the current running process. We also noticed technical improvements in the exploits themselves. So as Volodia got better and more experience, it started to using more effective arbitrary read and arbitrary write primitives. We also noticed that it fixed a bug in these primitives between two CVEs a few years ago. He also started to write a more modular code and split large functions to smaller subroutines. And this, of course, is best practices in programming, but also for us as reverse engineers, it's easier to reverse and understand each function in the binary. Also, the way he searched and accessed specific offsets in various structs was also improved. Now, in more recent implementations, it was more dynamic and safer, as it better handled changes in minor versions of Windows. And overall, we can say that the exploit became more sophisticated and better implemented. So we talked about Volodya, and now it's time to ask who were Volodya's customers. And this table we made is showing the CVEs that we were able to attribute to Volodya. And also it shows the customer that purchased the exploits from Volodya. And CVEs that are marked with blue are 0 days and naturally more expensive. And the highlighted groups that you see on the left are APTs. So we are seeing a mixture of both crimeware like QRSNIF and Magnibear, and APTs like APT28 and Tula. And we can see that Volodya's most happy customer was URSNIF or Dreambot, which is the Japanese campaign. And at least until 2018, they bought 5 exploits from Volodya. We can also see APT28 buying 2 0 days back in 2016 and 2017. And another interesting story here is Buchtrap, a group that started from cybercrime and then, as ISAT revealed last year in VB, moved to cyber espionage, most likely under the Russian government. So let's have a quick conclusion, what we learned from this research, what we learned from this presentation. First, we understand that our research methodology worked. Fingerprinting exploit developers, hunting for their exploits is possible, and it worked fantastic for both Volodya and Playbit. We found 16 Windows local privilege escalation exploits written by these two developers, by Volodya and Playbit, between 2015 and 2019. And this is especially interesting because it is a significant share of the exploitation market, specifically for Windows LPE exploits and specifically for Volodya. But we need to remember that these are only exploits that we found in the wild, and we are suffering from the survivorship bias. We know only what we know, and we cannot help but wonder how many more exploits are out there that we did not catch yet. We saw that the customers of such exploits were both crimeware and nation-sponsored groups. It's very interesting to see that APTs like Tula or APT28 are buying exploits in addition to developing exploits in-house. And finally, and maybe the most important one, is that we invite you all to try this research methodology as well. So if you have the resources to do this, you might end up with a very, very nice results. And also, we highly recommend you to read our white paper, as it is very technical and contains more information about our research and the results. Very interesting information that we left out of this presentation. And that's it. Thank you very much.
Eyal and Itai, thank you very much for your presentation, and also thank you very much for joining us for some live Q&A. How are you doing?
We are great. Thank you for having us.
Great. So Eyal, firstly, yesterday we were talking about commoditization. Were you surprised to find that APTs such as APT28 are buying exploits instead of doing their own stuff in-house, or not surprising?
We weren't surprised to find APTs using third-party exploits because it was already documented by other vendors. We do, however, still figuring out when they are developing in-house exploits and when they chose to buy other exploits. Maybe it's price, efficiency, we don't really know yet.
Okay, and maybe they have specialisms of their own, which they do in-house, and then the more commoditized ones they buy in, maybe?
Possibly, yeah.
Also, Itai, you have now done a lot of work identifying these particular exploits and basically identifying these fingerprints. So in the future, do you feel you would be fairly quick to detect new exploits or never before used exploits from the same authors because you have their fingerprints now?
Yes, absolutely yes. Now that we have this technique and all the rules that we wrote in place, it will be rather easily to detect new exploits written by the authors that we mentioned in the talk. And also, we hope to find 0 days written by these developers, and it will be fantastic.
Yes, it will be fantastic. We've had some questions come in as well. Liam says, I think it was shown that Velodia sold exploits on legit markets too. Did you find those as well? Legitimate markets.
Well,
He says like Zerodium.
well, we don't know. We don't have information if Velodia sold exploits to Zerodium. So we don't know this one, but for sure he was selling to threat actors, which are nation states. So the legitimacy of this is another discussion, I think.
Yeah, maybe something for VB 2021. You never know.
Maybe.
Ellen Itai, thank you very much for joining us live. And there's some bits and bobs coming into the Q&A. So if you could jump into the chat now, that would be fantastic. Thanks very much.
For sure. Thank you very much for having us.
Thank you for coming in. And thanks to everyone at home for your questions as well. Now, throughout the show, by the way, I'm just going to be featuring bits of memorabilia from past VB conferences, one of which may possibly be a clue to next year's location. So most of them won't be a clue. It's just a walk down memory lane, but one of them will be a clue. So get guessing. Jump in the chat if you think you know where next year's location will be and mark it #VB2021 and tell us you think you know where it is. But that was an object of beauty. Bigger, a lot bigger than the VB2020 mug. But this one's unique. So get bidding. Oh, bidding is going up, by the way, as well. The Mugtion, we are at $110 at the moment, it looks like. Fantastic. $110 for this unique item. Get bidding. Right. Now we have ML Security Evasion Competition 2020 with Zoltan Balash and Hiram Anderson.
Hi everyone, welcome to the Machine Learning Security Evasion Competition 2020. My name is Zoltan Balázs and I'm the head of Vulnerability Research Lab at Kujo AI. I had some offensive research in the past. For example, you might have heard about the Zombie Browser Toolkit, the Hardware Firewall Bypass Tool, the Malware Analysis Sandbox Tester Tool, or you might have heard that I played with some crappy IoT devices, or I invented the idea of encrypted exploit delivery via Diffie-Hellman key exchanges. Besides these offensive researches, I'm the co-organizer of the Hackerschule meetup here in Hungary, and I'm the program committee member of the Hacktivity conference. This is a joint research together with Dr. Hiram Anderson. He's an architect at the Azure Trustworthy Machine Learning at Microsoft, and he's the co-founder and co-chair at Chemlis organization. His background is from signal processing and machine learning, but he's also very good when it comes to information security. His main relevant research is that he created some code regarding reinforcement learning-based AV evasion, and he's also the co-creator of the Ember datasets. Machine learning is used in an awful lot of different ways in our life. For example, researchers can use machine learning to classify objects. And for example, when the machine learning model looks at a photo, it can decide whether there's a bus or an animal on this object. There was some interesting research done in the past to trick these machine learning classifiers. On the left side, you can see a normal bus, and on the right side, for the human eye, you can see the same bus, but because there was an added layer to this photo, if you try to classify the photo on the right, it will classify this as an ostrich. But we are in information security right now, so we are interested in malicious software detection. There were multiple research in the past how you can bypass machine learning based malware detection. For example, last year, some researchers found that if you extract strings from a game file and just dumbly append these strings to a known malicious executable, you can bypass the machine learning detection. I also did some research in the past, and 4 years ago, you could even bypass some machine learning models just by packing the file with a known packer like UPX. Luckily, this has changed recently, so you cannot use this trick anymore. Me and Hiram thought that there's a nice potential here to create a competition. So we created the website evademalwareml.io. And what you had to do is basically download 50 working malware samples and download 3 machine learning models with its weights, modify the malware samples to evade the detection by these machine learning models, submit those to our website, and if you achieve the highest scores, you could win this nice NVIDIA GPU. The outcome of this competition was pretty interesting. Around 70 people registered for the competition, and at least 11 were able to bypass at least one machine learning model. At the end of August, William Flashman submitted his latest samples and scored the maximum score you can have in the competition. I highly recommend everyone to go and check out his excellent blog post about how he was able to do this. You can also find other interesting write-ups. For example, you can check out Jakub Debski's or Fabricio Cheskin's research and how they were able to bypass the machine learning models. For example, it might be interesting to see whether you can bypass detection by using a packer. Packers were mostly used in the past to bypass AV-based AV signature detection, but turned out that because in this competition we are using binaries and some of these samples are already packed, adding another layer of packer on top of it might break the functionality of the sample itself. Another interesting solution was to add new sections to the PE executable. And for example, you can extract resources from known files like Microsoft files and add these resources to the malicious sample. Turned out, again, this can be very effective to evade the models in our competition, but unfortunately it broke some malware because some malware samples had packers or self-checks, and just by adding a new section to the sample broke the functionality. Fun fact, just by adding simple empty section to sample, you can even bypass some antivirus engines. I believe this is because of performance reasons, because the AV engine can quickly check how many sections are in a malware and only use those signatures on the sample which check the section size. So this can be a nice trick for your AV evasion. Last but not least, the winning strategy was to append some extra data to the executable. This technique is also called an overlay. And even though this is very dumb and plain, turned out this was the winning strategy after all. And Williams' solution was to brute force the ML models and found the pattern which evades all machine learning models. And again, fun fact, by significantly changing the size of a sample, for example, just by adding a lot of overlay to it, you might be able to bypass some AV engines. Again, I believe this is because of performance reasons. For example, here you can see one malware sample we are using in the competition. And if you are adding some overlay text to the end of the sample, you can see how the visual representation of the file changes. Some key takeaways from last year's competition turned out that the malconf and non-nec malconf machine learning models are a bit too academic and they are not very effective when it comes to practical malware detection. The LIEF project, which you can use to modify binaries, is awesome. And it's not that shocking, but dealing with malware is tricky because the IOCs they can produce can change over time, which makes it hard for us to detect whether this is the same sample or not. And there was also this added challenge that some pegged and protected samples are hard to deal with. I also checked some of the samples with the SSDeep hash, and it turned out that those samples which had either these repeating sections or some repeating overlaid data, they create repeating patterns in the SSDeep hash itself. And one interesting fact is that from now on, you can basically check the SSDeep hash of a sample, and if you see repeating patterns in it, it might be suspicious because in an average benign binary sample, there are no repeating patterns. There is no reason to do that. So this could be some way suspicious that, so for example, someone tries to evade a machine learning model with this technique. This year, we created a new Defender challenge on the top of the Attacker challenge, where you had to create your own machine learning model and submit it to the competition via Docker format. And in the Attacker challenge, you had to evade these previously submitted machine learning models, but now this was a black box attack compared to last year, where the challengers had white box access to these machine learning models. This year, our sponsors and partners are Microsoft, Kujo AI, VMray, and MRGF with us, but the main organizer people remained the same in the competition. And one reason why it makes sense to participate in our competition is that you can win Azure credits for your machine learning research plans. In the defensive track, we received 2 submissions which passed the minimum requirements. And you can see when you submit your samples that there are 3 models right now: the Ember model, the Need for Speed model, and a random string model, DOMOB. These are the malware families we have used in the Attacker offensive track, which ends at the 18th of September. At the time of this recording, this competition has not finished yet, so we don't know the results. The flowchart of the attacker challenge is that you go to the mlsec.io website, register there, review the terms and services and accept it, download the 50 provided malware samples. You somehow modify your samples and hope that it will evade all free machine learning models. We also hope that you check your malware functionality in a Windows 10 sandbox. And new this year, we have an API to submit your samples or query the results. If you don't like the web-based UI, then you can use this API now. And whenever you are satisfied with your samples, just create a zip file and upload it to our website. You can get up to 3 points for each sample based on how many machine learning models you evaded. And the highest score wins. But this year we are also counting the number of total API queries, which is counted whenever you check a sample with a machine learning model. And in order to claim your prize, your solution must be published on a blog post. As it was the case last year, please check that your file names remain the same in the zip file, otherwise we have no way to identify which sample is which. And besides the tricks last year, we have also some additional tips and tricks you can use to manipulate the binaries. For example, you can add or remove signatures, change the section names or properties, modify the import or export tables, create a TLS callback, change the PA header, maybe fix or change checksum, add, modify or remove the version information, create a new entry point, or change some code or data which does not affect the behavior of the sample. Still, it's not allowed to use droppers or self-extracting arrays, and multiple registration is against the rules and will result in immediate disqualification. Feel free to join our Slack channel. And last year and this year, if you are interested how we have created this challenge, it's all based on Python Flask admin, and we are using Cloudflare, Nginx, and GUnicorn for scalability and performance reasons, and we are running Python backend scripts, and we are using the VMRay sandbox to check whether the malware sample behaves the same as it was originally. As mentioned, we have an API this year. For example, if you want to submit your sample to all machine learning models and get an immediate feedback on it, you can see the API endpoint on the point 1. Or if you just want to submit your sample to one specific ML model, you can do that as well. On the point 3, you can see the API endpoint to get the results. Or if you already are satisfied with the results and want to upload your zip file with all the samples, you can do this with the API as well. Or you can query the specific zip status or query all samples or specific samples based on these API endpoints. This is all I wanted to share with you guys today, but please stay because here comes Hiram Anderson, who will show you an example solution which could have been used to win the competition.
My name is Hiram Anderson, and I'm delighted to present our work at Virus Bulletin Localhost. I'm going to be presenting the Machine Learning Evasion code walkthrough. This tool was included in the sample solution to the attacker challenge in the Machine Learning Security Evasion competition. You can download and play with this code by visiting mlsec.io and navigating to the attacker challenge GitHub repo. Our example solution was designed with the following things in mind. Number 1, the models to be attacked were submitted by contestants, in the Defender challenge that concluded previously. 2 models from the previous round qualified to be included in the Attacker challenge. In addition, we have hosted our own model to be attacked that is based on the Ember dataset. The models to be attacked report hard labels for submissions provided to them. That is, they do not provide a score between 0 and 1, but just a 0 for benign and 1 for malicious. Finally, we considered the leaderboard criteria while designing our solution. The first criterion considers the number of model evasions. With 3 models and 50 malware samples, the maximum score is 150 points. A tiebreaker would be decided by the efficiency in which the models were evaded, so we count the number of model queries. Thus, contestants are incentivized not only to be evasive, but also to do it efficiently. Contestants were able to choose any strategy that they like. To demonstrate one strategy, we released this example code on our competition's GitHub site. The code uses discrete optimization over functionality preserving file modifications using a package called HyperOpt, which ironically is often used for tuning machine learning models. You can learn more about the details from the code and documentation on the website. However, the broader strategy may be of general interest. It consists of employing an algorithm in part A to get the bulk of the malware to be evasive while remaining functional, followed by any additional manual steps in part B to fix any few remaining samples. We use the example code in our strategy in part A, in which we break our algorithmic attack into 2 phases: an offline attack against a known defender model for which we have code and weights, and an online attack. The hope is that many of the samples that were discovered in the offline attack will cross-evade the hosted online models without having used any additional queries against the API. You may visit mlsec.io to download this code. However, please be warned that when you run this demo code, you will write functional malware to disk. So please do so only using a Linux VM. To begin, we initialize the attack by analyzing a collection of benign files. The init subcommand extracts elements of the benign files that will be injected later into the malware. To launch our offline attack, we first run a local copy of the Ember model in the top window. Then in the bottom window, we'll use the run subcommand of our attack script, passing in malware samples that were downloaded by contestants. The tool will write successful evasion attempts to pass1/success and failed attempts to pass1/failure. Also included in each directory are history files that would allow us to resume our optimization of failed attempts. In the second pass, we begin with only the pass1 failures and iterate on the optimization, again storing successes and failures to a folder of our choice. Having now collected candidates that evade the Ember model, we use those candidates as seeds for an online attack, which now counts against our API query usage. The online attack is enabled with a simple -- online flag. After several iterations, we can now gather the successfully evasive variants and create a zip file to be uploaded to the website. Since there is a chance that the file modifications have broken some of the files, contestants have been encouraged to run the samples in a Windows 10 sandbox to validate functionality before uploading to the competition website. As a final note, Since the hosted models may learn from the queries issued by contestants, there is a possibility that an evasive variant discovered by a contestant at the beginning of the competition may no longer be evasive to a model by the end of the competition because the model has changed its state. We're recording these talks prior to knowing the winners of the Attacker Challenge. I would like to preemptively congratulate those who have won our grand and first prizes respectively. In order to receive those prizes, the contestants must publish or blog about their solutions. I look forward to learning about the winning competition strategies and would like to thank our sponsors and partners for making this competition a reality.
Thank you very much, Hiram and Zoltan, and thank you for joining us live in the studio for your questions and answers. Welcome. Now, you said that you were looking forward to finding out the winners. So, Hiram, the Defender Challenge, who won and what was the solution?
Yeah, so there's 2 winners in each round. There's a grand prize and a first prize. The grand prize went to a team from the Technical University of Braunschweig by Edwin Quiring and a team of students managed by Konrad Reich. And their solution was really interesting. It actually used an ensemble of machine learning models of different feature types and different model types in an effort to be more robust to evasion attacks. And then the sort of the runner-up prize was by Federico Ketchin and Marcus Bodashin from the Federal University of Paraná. And they have actually published a paper about their defensive solution that we'll post perhaps in the Q&A.
That would be great if you could paste that in the chat. And also there's some questions for you in the Q&A chat that are probably best answered in the chat. So that would be great if you can go and answer those. I just wanted to say as well, though, I love the model of your competition. I love the fact that instead of the attackers just attacking you, if you like, the organisers, the attackers and defenders are competing against each other. I love that, absolutely love that. But we need to go to Zoltan because we need to find out the winner of the Attacker Challenge and what was interesting about that winning entry.
Yes, so actually the Attacker Challenge was won by Fabrizio and Marcus, the same guys Hiram already mentioned. And they had some advantage because one of the models they had to attack was their own. So they knew best how they can attack that. But basically what they did is they used some XOR or base64 based encryption and also added some dead imports to the files. And they were able to bypass all 3 models with these simple tricks.
Well done to both the attackers and the defenders. But I do like the strategy of if you're on both sides, it makes it a little bit easier for part of the challenge for you. So that was an interesting way of doing it. We've also got, Leandro wants to know, is there an index with all the published solutions? So again, maybe you can drop that in the chat. That would be good.
Yes, definitely.
And Alexander wants to know, have you thought of introducing exercises that require attacking machine learning models of AV's behavior blockers?
I would say the simple answer is no, but we have spent like 2 minutes thinking about this and it is pretty hard to do that.
Okay. I have to say the 2019 winner, you said, was a very plain solution and they basically won by brute force. Were you expecting that, or were you expecting a more elegant solution to win in 2019? I mean, respect, because it won, but were you expecting something more kind of complicated to win?
I always prefer simple solutions. So in this case, it's a very elegant way to win. But on the other hand, we were expecting something more sophisticated to be the winner.
Excellent. we are out of question time, so we're going to have to leave it there. But thank you to both of you for joining us. I think actually you're going to get a lot of requests for your magazine that you featured there, with the article on comparison anxiety. A lot of people asking for a friend there, so you might actually have to publish that. You thought it was just a joke. But thank you very much for joining us in the live Q&A. So if you could jump into the chat now, that would be brilliant. And yeah, there is stuff coming in for you there. Good to see you both.
Thank you. Bye.
Thanks, Angela.
And now we have another presentation with another live Q&A coming up. It's hunting for malware with command line logging and process trees. And that is from Vanya Svacha.
Hello everybody and welcome from sunny Croatia. Today I'm very sorry that I'm not able to see everybody live in Dublin, but it was the best decision to postpone or cancel the person-in-person conference. But the silver lining to the cloud, of course, is that the conference is now free for everybody and there are so many people now watching. A lot of them probably just thinking about getting in the computer security, and I say especially hi from them and would like to quote from the famous Hitchhiker's Guide to the Galaxy to say, don't panic. So what are we going to talk about today? So the title of the presentation is Hunting for Malware with Command Line Logging and Process Trees. So that essentially means that we have two tools that we can use. One of them command lines and second the process trees. And we will dig into quite a lot of details, but the presentation is kind of medium technical content, so it's actually good for the beginners and it's good for the people who are practicing and working in blue teams as defenders in various types of organizations as well. So I will just say a few words about myself. I currently work as a security researcher at Cisco Talos. And I have been, as you can see, within the industry for longer than I can remember. I was working on so many malware research projects and researches of various campaigns. I was interested in automated analysis, mobile malware, various types of debugging tools, and recently I was looking quite a lot into how we can process the telemetry data and extract interesting information that can be applied to detection techniques and also to protection within the organization. And this is where the actual idea for the talk came from digging into that telemetry. So what are we going to cover today? First, we'll briefly cover the motivation for the talk and the motivation for the paper, as well as the context. Then we will talk about how to set up and what the most important thing when we considering working with command lines and process trees is the visibility. And we have to mention so-called leaving of the land binaries because they are essential part of what are we going to try to hunt when we're looking at the command lines. Then we'll talk about the command lines a little bit and the process trees, and then how we can use both of them, one or the other or combined, to hunt for known and or unknown malicious TTPs. So a little bit about motivations. There is a trend today towards using those legitimate binaries where there's very little code, malicious code that's present on the disk, and most of it is present in the memory. So we're talking about the fileless execution, and it leaves a minimum footprints and traces in the operating system. As such, it's a little bit more difficult to detect, although it's not impossible to detect. And I think as the whole industry, we have already changed the mindset from the idea that we can actually protect all of the assets we are protecting to the fact that we admit that we won't be able to do it, and therefore almost certainly we already have a compromise in our system. So we would like to detect what's going on. And those tools, we have many tools there, but today we're going to concentrate about in command lines and process trees, because those are the two tools that can be easily extracted not from some super sophisticated programs, but rather from logs of the operating systems, and specifically we will concentrate on Windows logging. And we would like to find ways that will help blue teams to detect new and malicious activities within their organization. So first of all, we need to have visibility. The visibility can be achieved in many different ways. You can have EDR tools that will help you to do that. You can have system monitor, Sysmon, which will then log all of the events into the event log and then forward to the centralized logging facility. But possibly the easiest way to do it is just to set up a Windows group policy for process logging, and it's a simple process logging policy. You can see audit process creation is the setting, and you have to enable that setting. But before you can actually collect command lines, you also have to enable inclusion of command lines in process creation events. So that's just another setting, and it's very easy to change. So once when you have that, you are looking for the event number 4688, and from there on you have to be able to forward those log into some kind of log aggregators, whether it's a Windows logging aggregator or some SIM utility or like elk stack or whatever you're using later for the analysis. In our case, we are collecting our telemetry data and putting it in a quite a large Hadoop cluster in a Parquet structure file format, and then we are using Apache Spark to run various analytic jobs on that data and extract all the interesting information. So when we talk about all the command lines and when we talk about process trees, one of the major things you will encounter when investigating the logs is the usage of so-called lol bins, or living on the land binaries. Those are the files that are already present on the systems. They are completely legitimate files, but they have some side effects that can be used, or if you want to, abused by the malicious attacker, but also by the red team members. I won't dig deep into all of them because there are like 50 of them or even more on Windows. But please feel free to refer to the LOLBus project, which is a LOL bins and scripts project that started by Odvar Mo, a researcher who really is dedicated to it, and he always updates this project with the latest LOL bins as they are being discovered. When we talk about LOL bins, possibly the most commonly used one will be PowerShell. That's how I started my research. I started looking at the PowerShell command line specifically, trying to look for the suspicious invocations of the PowerShell, but also trying to, for example, decode the script which is supplied as a command line argument. Usually it's a base 64 encoded script, so it's relatively easy to decode, and malware is also often using that. And I was hoping that when I was looking at the logs that I will mostly find malicious usage of this encoding. Of course, like everything else, your hypothesis doesn't have to be proven truth in the end. So I found so many completely legitimate tools that are using the same technique or tactics. So PowerShell is great because it's built on top of .NET. There are so many modules available. You can have in-memory execution with various types of loaders in. There's ability to obfuscate code, and there are so many different off-the-shelf modules that you can use, and security frameworks for kind of malicious actors, but also for the red team members. So what I was looking for with the PowerShell are invocation with the command line options matching IX, so invoke execution commandlet, anything with invoke, bypass, hidden, encoded script, or enc. Usually the malicious ones only have like 3 minus enc, because with PowerShell you can use, as long as there are no double words. PowerShell wants to be very helpful to you, so encoded script is almost the same as enc. So it takes both of those command line options as completely correct parameters. And in the end, I realized that out of all of the suspect ones, so there are actually quite a lot, there are approximately only 1 in 1,000 invocations of PowerShell with the suspicious command line options are actually malicious. So then I had to lower the amount of data that I'm looking at, and I realized that a lot of the times you will have a URL in the evocation of the PowerShell because some additional code is sometimes applies as a part of the variable declaration, and sometimes it's just after the deobfuscation you could see a URL where the downloading code, where the downloader downloads code from. And then in that case, I actually found about 7% of all of the URLs in suspect PowerShell invocations are suspicious. So I concentrated this, and then from then on, I was able to almost like manually look at everything and was able to find interesting stuff from PowerShell. So what did I find? There are so many off-the-shelf tools. Actually, first of all, there are a lot of malware families, from ransomware to some kind of password stealers to exfiltration techniques that are employing PowerShell. And like I said, there's one of the main modules that are used is reflective DLL loader by Matt Graber, who documented it at one of the conferences. I think the talk is available on YouTube, so you can search for that. And so there are frameworks such as PowerSploit, PowerShell Empire, and so on. But there are also some of the custom-made tools which are not like ready-made. I think I already mentioned that not just the malicious actors. When you look at the command lines, you will encounter a lot of noise as well, but also activity which is worth detecting, but it's part of the red teaming exercise. So you have penetration testers that are testing the security of your organization, and sometimes those are announced and some that are unannounced. But here's for example an example of some ready-made tool that kind of mimics Mimikatz that tries to steal credentials from memory, but these guys obviously have some sense of humor, so he says that Benjamin Delpy is a very funny guy. So I really looked at the invocations of about 20 different lol bins, but those 5 proved to be possibly the most interesting ones. Microsoft HTML application loader or interpreter, certificate utility, bits admin, reg server, and PowerShell in the end. So and you could see that roughly between 99.8 and 98.5% of the malicious of the executions are actually completely legitimate, and only a very few of them are malicious. So your task as a blue team member is to separate the signal from noise, and maybe those command lines and looking at the command lines and process trees will help you to do that. We'll see that later. There are some limitations when looking at the lol bins. It's very easy when you have PowerShell and maybe some other scripts where you have a URL and you can download that code from the URL to see exactly what's happening. But if you only have a file name as a parameter, often it's impossible to decide whether this invocation is malicious or not. You can look at the parents of the process, you can look at the full path of the parameter of the file that's added as a parameter, but you won't be able to make this decision for sure. I was actually looking at MS Build. MS Build is a system which allows you to build projects in .NET framework, and most commonly you have a C# project file, CS project file, where it's an XML type file where you can include some code as well. And you include code by creating a special tag, an element, using task, and basically it allows you to, it's called inline task, and you can actually override or you inherit from the task class, and you can either override the complete class, or you can override just one method which is called execute, or you can just override a fragment of the code which will be executed when you are creating a C# project. So here we see an example, and I've seen so many different things abusing Microsoft Build, where a code is downloaded on the disk that can be obfuscated, and then C# project is loaded. Here we see a standard Metasploit shellcode, and we have also seen Cobalt Strike loaders in shellcode, just to allocate some virtual memory to have execute read-write permissions, copies the shellcode into that memory, and then creates a thread and then loads the code, which then further downloads the interpreter in the end. So the next thing we are looking at are actually process trees. What are the trees? Well, trees are like subset of graphs, and graphs are structures where you have nodes or vertices, which are these kind of round shapes, and you also have relationships between them, which are also called edges. So here we have a graph taken from an automated analysis system, where we see that the WinWord is launching MS Build, which is launching C# compiler and Internet Explorer. So this is like a small tree of different processes, and the relationship between these processes is execute. So WinWord executes msbuild.exe, or you could say WinWord is a parent of msbuild.exe, or msbuild.exe is a child of WinWord, and you can define all these things. So we will be working on these process trees. In order to have process trees, you don't just have to you don't need to have just processes. You can have many different types of objects. For example, you can have TCP/IP addresses, you can have domains as objects, you can have unique machine ID, you can have organization ID. Especially if you are an anti-malware vendor, you will have more than a single customer with more than a single machine. And so first you define objects in the database schema that you're interested in, which will build your tree, and then you also define your relationships. So we have a process that executed some other process, created some file, connected to a TCP address, and so on. So you have to define it for yourself, but this is just like a proposed database schema that can be used for hunting. And how do you then actually hunt? Well, once when you have your command lines, you find the processes that are interesting in any kind of ways. For example, it could be a PowerShell invocation with some suspicious command line options, and then you traverse one level up until you find the known system process. So if it's a process is explorer.exe or system.exe, you more or less know that you have reached the beginning of the tree or the top of the tree. And then from each child of the process, you traverse its own tree of processes, and then you collect suspicious files and retrieve them, and then you kind of build pictures or build picture of what this, if it's an attack, what this attack look like. So now that we know how to hunt and what's roughly the hunting process, let's see how we can look at and try to find some of the known malware examples. This is the case a few months ago when I was looking at the activity of China Chopper. China Chopper is a web shell tool that has a GUI, and on the server side there's only like a single line of code that includes. It supports PHP and Java and ASP on the server side, and you can actually also have a command line, and every time you open the command line and send a command, at the end of those command lines, and here we see request that's a base 64 encoded, but when you there's only like an eval statement in the test variable, but when you decode the test variable, you see that there are several variable names. One is Z0, the second one is Z1, and the third one is Z2. Z1 contains the code that's used to process the rest of the commands. So here we see that it takes the Z1 parameter, which is the process that needs to be launched, and then Z2 parameter is the one that are the command line parameters, but at the end you see that it says echo S and CD and echo E. So those several characters would be enough in the command lines to look for the presence of them in the command lines. And this is how we're actually able to find many of the live examples of China Chopper in several organizations. Possibly, and now we'll see just one of the examples, is an example of one of the ministries of the Eastern Asian country, where we saw the activity of an actor that was collecting the documents using a renamed WinRAR and saving those documents in a RAR archive with quite a long password, and then trying to exfiltrate that data. Before exfiltration, we also saw that there is a special downloaded module called helper.ps, which was connecting to the MySQL database and basically dumping the content of the database into the file and then zipping it or RAR archiving it and then sending it to, just copying it to the computer where we didn't have control on, but it was obviously a part of the whole exfiltration. So this is how you kind of hunt for the known attacks. You need to find a specific signature or specific pattern that you're looking for in the command lines, and as long as that pattern doesn't generate any false positives, you will be able to find quite a lot of data. How to find for unknown attacks that you don't know about? But let's consider a simple process tree. So because there is a lot of data that we'll be dealing with, and if you work for an anti-malware company, you are dealing with billions of records every day. So you can't afford to look at the whole process trees. So you need to find some simple subtrees. One of the simplest graph subtypes you can look at is a triplet, where we have a grandparent and parent and a child. The triplet is very simple, and there are so many graph databases and frameworks which will allow you to search for certain types of triplets. So how do we approach searching for triplets? So we first have to be able to generate a database of triplets, and from then on we are looking at either a known child or a parent or a grandparent that's potentially suspicious, and then we traverse the tree to look at the rest of the files, and therefore we see and find other nodes in the potential attack. The second similar example is when we only have a parent and a number of children, let's say 3 children, and there we look at either one child or a parent, and therefore look at traversing that simple tree of 4 nodes, and we can store it relatively easily in the databases, and the search for the interesting ones can conclude in a reasonable amount of time, which is usually 3 hours when you're dealing with big data. So here are some case studies that we'll be able to find or hunt and detect using these techniques. First of one is very recent. It's a Prometei botnet. It's dedicated to Monero mining, but it also has many different modules, over 15 different modules, credential stealing modules, brute force password modules, credentials validation module. It laterally spreads using SMB and exploits such as Eternal Blue. And the whole search starts with this simple command line, where I saw that PowerShell is being used to download a module, but before the module is used, it was XORed with a simple XOR loop, which is very suspicious. And from then on, we actually found the MIWalk module, which was a modified Mimikatz module. And then we also look at the database or debugging path into it, and from the debugging path we were able to create Yara rules, and then we hunt for the rest of the modules either on the product side or on the open source threat intelligence side. And here's what we found out. So we started from MIWalk, which is somewhere in the lower right side of the screen. We have 2 major branches. One is dedicated to spreading using SMB. The second one, NV stub branch, is dedicated to collecting and validating the credentials. And we also have svchost.exe, which is dedicated to connecting as the main bot module, and it provides the backdoor into the infected system. So just from a simple command line, after some work, we were able to build quite a detailed image and find a lot of details about all the modules that are used in this Monero mining botnet. The second example is found by decoding, base64 decoding, again, PowerShell command line, and we found this download string from GitHub user content, which was, when decoded and deobfuscated, was an actual PowerShell loader for Azeroth credential steal Trojan, but it wasn't just the Azeroth. So here we found the PowerShell loader, and from the PowerShell loader we were able to look at the parent process of that PowerShell, and we found that the parent process is an executable loader. And then we also look at the relationship of not executed but also contained, and so we found an ISO image that contained this executable loader, and we also found a zip file which was possibly sent as an attachment which contained the ISO image. So again, you traverse the both sides, and from the PowerShell loader we saw the number of files or modules that are being downloaded. One of them again was XMRig Monero miner. There was the Azeroth credential stealer, Remcos remote administration tool, Dark VNC administration tool, and a clipboard stealer which was focused on stealing and modifying the clipboard when the Bitcoin or some other cryptocurrency address was pasted into it, so to hopefully modify the transaction for the bad guys. And that was it for me for today, and soon I will be able to answer the questions live from you. I hope you enjoyed it, and I hope you found command line and process tree useful tools that are very practical and that can be used in a day-to-day hunting to improve your chances of finding compromise within your organization. With that, I would like to thank you so very much for listening, and I will open to the questions.
Thank you, Vanya, and welcome to the live Q&A session. Thanks for joining us in the studio.
Thank you. I'm very happy to be here.
When I say in the studio, it's obviously remote, but
Yeah.
it's getting late on a Friday night and you've still joined us, so that's very kind of you. Thank you.
Well, for some of them, it's very early in the morning.
But for
our
you,
colleagues in the US.
Now, quite early on in your presentation, you said that of the suspicious executions, when you looked at that, the number of ones that were probably actually malicious was about 1 in 1,000. Is that about what you might have guessed at before you did so much work to find that out? Or did you find that surprising?
Well, my guess was that I was hoping that the number would be actually higher, because we are dealing with billions of records per daily basis. So you want to be able to filter those records to the manageable number where you are able to then more or less manually look at the maybe hundreds of records rather than thousands and hundreds of thousands. So yeah, I was a little bit disappointed, but it turns out that for some of them, it's still doable. It's still possible to create some of the rules that will then allow you to do manual analysis.
Mm-hmm. Now, something we've been looking at in several of the presentations over the last few days is trying to avoid detection. What techniques could be used by attackers to avoid detection using command lines?
Well, just looking at the command lines, it's a very rudimentary technique for detecting something. You know, you're just looking at how a certain process has started. So there are many different ways how the attackers can do this. One of the things would be certainly avoid PowerShell, because we can see quite well when the PowerShell has been used, and the full command line will often give you indication that something is wrong. There are other living of the land binaries, and there are new every month or so a new one will be discovered. So I guess for them it's to find some new ones or avoid ones where they will be very suspicious immediately as soon as we see them.
So keep moving, keep changing. Now, you have got another publication coming out, haven't you? This time on new techniques in cryptocurrency mining. Do you want to tell us a bit about that? And then maybe when you go into the chat, drop a link in the chat to where it will be, where we'll be able to find it.
Well, it would be part of our blog, Cisco Talos blog, and it's really built on top of this paper where we found some relatively interesting new techniques in a botnet, which was already previously documented, but we have seen increased activity in it, and this would be our take on the botnet, which is called Lemon Duck.
So if you've seen increased activity, does that mean that's something else you're keeping your eye on as well, ongoing?
Yeah, I mean, we are keeping on many of the known and botnets, but what we are really trying to focus on would be the new, completely new operations. These are the ones that we've tried to focus on, rather than the operational one that we follow and track. My team is specifically tasked to look at these completely new threats, which we then share with everybody around the world.
Okay, and there's one just come in, but we're going to have to be really quick because we're out of time. Leandro wants to know which different graph solutions would you recommend to perform these kinds of hunts?
Well, I've looked at a few of the graph databases, but what's available to me is Spark, and Graph Frames is a framework on top of Spark data frame, which I then use regularly. Okay,
great. Thanks for the recommendation. And if you could jump into the chat, that would be brilliant. And thank you so much for joining us live on a Friday night.
Thank you. It's my pleasure to present at VB as always. Thank you. Bye-bye.
And now we are heading for a break. We're in the break. But don't forget to keep bidding for this wonderful VB2020 localhost mug. The main run never got printed. So there you go, that is the VB2020 mug. At the moment, the bid on this stands with Veronica, who is bidding $110 for the trees, she said. So she gets the mug, the money goes to the trees, saving the forest. Also, we have some guesses coming into the general chat on where VB2021 will be. Now, I've been just putting bits of memorabilia out as we go along. Some of them may be clues to where we're intending to be next year. Some of them may be decoys. Incidentally, for those of you who were wondering, the beer stein was from 2013, and the little clock that I had in the last introduction was from 2008. So I don't know if you want to use that as clues as well, maybe. And we have this as well from 2010. I can't tell you if that's a clue or a decoy. So far the guesses are: Soren thinks that VB 2021 is going to be in Munich. Veronica thinks Buenos Aires. Ricard has said Cancun, but there's an explanation for why he thinks it's Cancun, because VB 2021 is the Viva Aerobus flight code for their flight to Cancun. So there's some logical or possibly even lateral thinking for you. Eddie thinks that VB 2021 is going to be in Dublin. And then a couple of minutes later, he said, or maybe Hawaii. Okay, because that's not a different part of the world at all. So Dublin or Hawaii for Eddie. And then Ricard also, so we've got two guesses here as well. So Cancun was the first guess, but then the second guess was Prague. The reasoning for that is, I'm loving your reasonings for your guesses, Ricard, here. The hint one was the beer mug. sponsored by Avast in the past, okay. Hint 2 was the watch astronomical clock. You see, this is where my knowledge of Prague lets me down. I don't even know if there is an astronomical clock in Prague. But there you go. Certainly Ricard's doing some detective work. So well done. Keep the guesses coming. Keep the bids on the mug coming. But also remember that not only for the rest of today, but afterwards, you can also look at the on-demand presentations. And if you haven't been to the Threat Intelligence Practitioners Summit, go and check that out too. There are the partner booths. We've got the CTA and we've got Bitdefender in their partner booths. Drop in for a chat. There's been some lovely chat going on there. And we will see you back here at 17:45 UTC for our next presentation. Meanwhile, I think we've tried a lot of bells so far and I'm not sure we've got the right one yet. I'm sorry, we continue the search. I'm going to see if I can find a bell as good as the traditional VB bell to get you back from this break. Wish me luck, it's raining out there. Well, yesterday we tried a segue. This time we're trying conference campanology, but are any of the bells we're trying any good? Please let me know. I'm a newbie. I've never been to the VB conference before. I'm trying to track down the ultimate VB conference bell, but for now, let me know how the newbie's doing. Right, back to VB 2021 though, looking ahead. Greg thinks that Munich could be a goer. Jeanette thinks it's going back to Jersey, back where it all started. And Chester thinks it's going to be on YouTube. We've also got Alistair, forget the years, it's a big chance the virus doesn't go away, so try getting a list of territories that have 0 cases of COVID, which brings Lucas to suggest New Zealand for next year. Keep the guesses coming. I'm not going to tell you if you're wrong or right, and I'm not going to tell you whether these are hints or decoys. I'm going to leave that up to you. So now we're on to our next presentation, which will be followed by a live Q&A. So get your questions in to the Q&A chat. Put hashtag #AskNow to show it's for the live speaker. And this presentation is Tonto Team, exploring the TTPs of an advanced threat actor operating a large infrastructure. And that is Daniel Lungi and Jaromir Horeshi.
Hi, I'm Daniel. I work at Trend Micro. And with my colleague Jaromir, we will show you the result of our investigation on the Tonto threat actor. So this is the outline of our talk. After a quick introduction, we will see the history of this threat actor. We'll discuss the different infection vectors that we found. Then we will see the custom share backdoors and posted protection tools that this threat actor uses. Then we'll see the infrastructure, targets, and further links that we found. Then we'll conclude and show some references. So this is an advanced threat actor likely based in China. It has many names. The more famous and used one would be Tonto Team. It is also known as Cactus Pit, Lone Ranger, and on our side we use the name Earth Aklut. So this threat actor has been operating for more than 10 years, targeting multiple government organizations and worldwide companies. The first public report on this threat actor was Herbit campaign written by Trend Micro in 2012. But the older malware discussed in that report dated back to 2009, so this threat actor has been here for a long time. Then some of our colleagues presented Operation Orca in this same conference, Virus Bulletin, in 2017. In 2018, Anlab and Palo Alto published some reports on this threat actor. And this year, Talos published a report on the Bisonal malware family. Then our report will be published on the Virus Bulletin website after this conference. So why this name? In the Trend Micro naming convention, EARTH refers to a campaign related to espionage or information theft, which applies in this case. And then we use a name of a legendary creator. So we found this Aklut creator, which is half wolf and half orca. So this was a reference to the previous work of our colleagues. So let's see now the different infection vectors used by this threat actor. We found 3 of them: phishing websites, spear phishing emails, and the exploitation of vulnerabilities. So this is a screenshot of a phishing website used by the threat actor, which is the exact copy of a legitimate website from the Mongolian government. The only difference that we found out by analyzing the code is that the script called after clicking on the submission button, in this case, will forward the credentials to the threat actor. So as you can see, the domain name, the registered domain name is also very similar. They only replaced the dots with dashes and added .com at the end. So what we can do to lower the success rate of this kind of attack is raising the user awareness on this, because the threat actor requires strong user interaction, because the target needs to first follow a link and then enter the credentials on the website. And on our side, we blocked this website as soon as we found it. So also the threat actor uses spear phishing emails with malicious attachments. This is an example of such emails, which was sent on the Labor Day, and it is related to the working conditions in the defense industry. And as you can see, there is a malicious attachment there. This is another example. This was a fake resume sent to a job application. And This one was a more recent example for a summit in the aerospace and defense industry, which are both sensitive industries. So the attacker used multiple RTF files which exploited known unpatched vulnerabilities. And they used the infamous Royal Road toolkit, which has already been discussed and researched by other researchers. And it is known to be used by multiple threat actors, most of them in China. So in this case, for a successful attack, the attacker requires user interaction again. So we can still educate our users about this kind of attacks, but we can also apply updates because in this case, as all the vulnerabilities were patched, so this would have prevented the code execution in this context. On our side, we also blocked the malicious samples on CNCs. So this is the third infection vector, which is the more advanced one. And it exploited two different vulnerabilities in security solutions. The first one was patched last year, and the second one was patched this year in March. So while this infection vector is the more advanced one, we only found it in a minority of the cases during our investigation. So also it should be noted that both vulnerabilities are required for a successful attack, which means if only one of them is patched, then the attack does not work. Also, the attacker in this case chose to deliver the ShadowPad malware family, which is an advanced malware family which will be discussed later in this talk. So in this case, there is no user interaction required, but there are still a lot of requirements which are listed here. First, the attacker needs network access to the management server. So if, for example, the management server is restricted to the internal network only, the attacker cannot access it. Then, once the attacker got this access, it still needs to somehow bypass the authentication. And even after being authenticated, this management server is not intended to execute code on the endpoint. So the attacker still needs to find a way to execute this code. And this is where they used the second vulnerability. So what you can see here is that all of these conditions can be mitigated either by network design, so as I mentioned, by restricting the access to this management server only to internal network or through a VPN, for example, and also with a proper patch management, because as both of these vulnerabilities are patched now, the attacker cannot use them anymore. On our side, we also blocked the payloads on the CNCs. So I will now let Jaromir discuss the different backdoors used by this threat actor.
Let's look at the backdoors of EarthAcute. So this is the overview of all the backdoors we have seen. So it started in 2009 with Heartbeat. Then it followed like different versions of Bisonal, Chimera, Dexbea, and so on. All these backdoors you can see, except the last one, are written in C++ and use often like some other libraries like MFC. The last one, IDLES, is written in Python 2.7, compiled with PyInstaller. So we will not talk about every or each of these backdoors like one by one, but we will overview or look on some features which they have in common. So when we talk about the commands, so we can see that all of them support the basic commands like for process enumeration, downloading files, executing them, and interactive shell. Most of these backdoors support file uploading for file exfiltration, deletion and termination process, and some of them implement more extended operation system information collection, uninstalling, and also wiping files. When we talk about operation system information, they usually collect things like IP address or code page, so which says basically like what kind of country settings is set in the given machine, time in terms of tick count, so how much time the infected machine has been running since the last reboot, operation system version, token information, which are the privileges of the given user account. Then they collect computer name, whether there is proxy or not, whether it's run in virtual machine or not, and also the campaign ID. Very important information is the configuration of each backdoor, and we usually care about CNC and in some cases it's not encrypted, it's in plain text, but mostly the XOR key with the given keys are used. In some cases, we have seen usage of RC4 with hard-coded password in hexa 1, 2, 3, 4, 5, 6, 7, 8. But the most interesting encryption is the custom encryption using these atypical constants, 58BF and 3193. So basically in one backdoor called XDSpy, we often notice these kind of longer strings in capital letters. So the decryption algorithm has two steps. In the first step, it creates some kind of like intermediate representation, which is then decoded to the URL address itself. So this Python code describes like the decryption process step by step. So there are like two loops. The first loop take usually like two following characters and convert them to one character, and later this one character is decoded with some key, with some XORing, multiplication, and so on, with using these untypical constants. So when we search for these constants, we find that the same constants have been used in Adobe Type 1 Fort format specification. So when we open the specification, you can see these constants in decimal code. After decoding to hexadecimal, we get our constants. We should also remind that if you try to search for it, if you try to Google for similar constants, you can find similar results in some security products, for example, using them as the means for encrypting their logs. For network encryption, in some cases, of course, the network traffic can be in plain text unencrypted, but mostly we have seen like different versions of encoding or compression, like hex, zlib, base32, base64, XOR encryption, RC4 encryption, zlib followed by RC4 encryption, or RC4 with 128 byte state vector. So normally the state vector has 256 length, but in this case we have seen only like one half, like 128 bytes. So this example of network traffic of one custom backdoor, which is called Chimera. And you can see that in the GET request below, there is some hex encoding, which is the way how this backdoor communicates with CNC server. Also notice like on the top, there is this user agent, and it contains like various interesting information like flag, host, and IP, which are basically some information about the given machine. We often seen some virtual machine check, and usually is this virtual machine check checking only for VMware. We have seen like several cases of sandbox evasion. This one, there is like time delay. So basically it initiates one variable with value 0, then it computes MD5 hash and compares this with the string EF something. And then if it doesn't match, the value is increased by 1. So when you search for MD5 hashes, you can get there's the number with 8 digits, each of them is 9. So it takes some time, and after this delay is finished, then the main backdoor function gets executed. Another interesting sandbox evasion is this one, that there is basically it creates a request to a non-existent website, and if the request fails, it means that the backdoor is running in the sandbox. However, if for some reason sandbox returns like meaningful response to the non-existent URL addresses, then it's considered as detection of the sandbox, and execution doesn't continue. So this is the code directly taken from the backdoor. Let's talk about Chimera backdoor, which was named after one Greek mythological creature. And also like we managed to acquire a control panel. It looks like this, and you can see the Chimera keyword as the title of the control panel. In this testing environment, you can see like one infected machine. After double clicking on it, we get another form, which allows us, for example, inputting some command, and pressing the CMD button executes this command. So which is interactive shell. There are also like lots of code similarities. So this screenshot shows like 2 examples for sending machine information about this flag and name we have seen before, and also campaign ID code, which is in the screenshot below. Both of them have been kind of shared between Chimera and some Bisonal versions of backdoor. So there are like some similarities. I often talk about campaign IDs. So how do they like? So in this page, you can see like different campaign IDs. Usually there are numbers, like the first one, 416 is probably date, the 16th of April. And we're also interested on some, for example, country codes. RU is Russia, MN Mongolia. You can see there, for example, MFA is like is likely Ministry of Foreign Affairs. Energy is probably some kind of energy related company, and so on. So the previous backdoors were custom backdoors, but we have often seen the shadow pet, which is backdoor shared with other threat actors. So in the past, there have been like some supply chain attacks in previous year attributed to WinNTI/APT41. It was until 2019, but since 2019, we have also seen Earth Occult using ShadowPad. This ShadowPad has several plugins. So this is the listing of the plugins which we have seen in the cases we investigated. So usually there are like 5 basic plugins. Occasionally there have been like 2 more, called TCP and UDP. This ShadowPad backdoor is loaded through DLL sideloading vulnerabilities of signed executables. They usually use VM-Protect for protection of the DLL library. They use lots of anti-disassembly techniques, so it's like more difficult to analyze these files. And as sandbox evasion, they usually check like for the parent process, kind of like parent process which loads the DLL. And if the parent process is, for example, run DLL32, it might indicate that it's running in sandbox and the execution of this case is stopped. ShadowPad also contains some configuration. After decrypting the configuration, we often see some version tag. Some of these version tags in the left column have the date, for example, 2020-0120, 2020-0220 is probably the date. However, if you look at the compilation stamps in the right column, you can see that these are not synchronized. So basically time of the building environment, likely some building machine, is not synchronized with the actual time of compilation. So now we will continue with a few post-exploitation tools. So these tools are either public ones, which use for example, privilege escalation, computation of hashes, various credential dumpers like gsegdump, lasagne, wdigest, or some tools for enumerating either network shares, keyloggers, or lateral movements like Eternal Blue. They are the publics. We also have like one private tool, which is called like domain info, which basically dumps information from domain controller. So this is the example of the output in some kind of output file. Very interesting is hub relaying, because this is like very kind of simple tool which listens on the CNC server. When the threat actor connects to the given port, then this tool starts to listen on another port, and then when infected machine connect to this second port, then the traffic is forwarded to the threat actor. So there's some benefits. So basically, if the threat actor loses control of this hub relaying tool, so they don't lose or they don't expose the backend logic. So this is only for forwarding the information. And now Daniel will continue with infrastructure.
So let's talk now a bit about the infrastructure of the threat actor. After analyzing the different malware samples, we extracted the domain names used as command and control servers, and we could group those domain names into clusters, usually by infrastructure overlap, which means multiple domain names would point to a single IP address at a specific time. And after monitoring this threat actor for some time, we noticed that those clusters were usually bound to a specific malware family, which means that all of those domain names, for example, from this cluster, would relate to the Dexbia malware family, and all of these other domain names from a different cluster will all be related to Bisonal malware family. So this was interesting in our opinion because it suggests that on the attacker side there are maybe different operators for every malware family. And also some numbers now, so from March to August of this year, we found 49 domain names resolving to an IP address, of which 38 were dynamic domain names. So this shows that this threat actor likes to use dynamic domain names. We also found 46 different IP addresses. So all of this shows that the attacker is pretty active actually, because all of this was only in a 5-month period of time. So now some mistakes also that the attacker made. They misconfigured some CMC servers in a way that allowed us to browse the content of those servers. So they were open directories. So we could retrieve those files and we could analyze them and find some new malware samples and even some new families that we did not know before, and some victims also. So this is an example of a file that we found on those CNC server. So if your eye is trained to this kind of stuff, you will notice quickly that there is a single byte XOR key. So if you apply this key, you will get this header for a portable executable file. So this was a malware sample. This is an example of the files containing victims that we found on these CNC servers. So if you look at the different fields a bit more closely, you will notice that there are the same fields that are retrieved in the type hash malware family. So these were all victims of the type hash malware. So a word now about those victims, those targets. We could identify 61 different targets in 19 different countries from January to July of this year. Taiwan was the most targeted country, followed by India and Russia. This is interesting because all the previous reports never mentioned Taiwan as a targeted country. So this shows that this threat actor actually targets more countries now than it did before. Regarding the industries targeted, technology and manufacturing were the most targeted, followed by education, healthcare, and also government. So this can be seen in this chart by here. Same for the countries. Here you can see that Taiwan was like 1 out of 5 victims was from Taiwan. So let's discuss now some links to other threat actors. We said before that ShadowPad was a malware family that priorly was an indicator of APT41, and we know it's not the case anymore. So now we know that multiple threat actors use this malware family. However, we still found a link to the tick threat actor. And this was actually an encryption algorithm that was used both in tick malware samples and in Tonto ShadowPad malware samples. The tick threat actor was discussed in Operation End-Trade report, actually, in our blog post. So this link we found suggests that both threat actors share the same builder for this malware family. There are still different threat actors, and one quick difference would be the delivery mechanism. In the case of tick, they will use a dropper named Casper. So let's conclude now about this threat actor. So we showed that this is an advanced threat actor with big operational capabilities because they are able to develop multiple custom malwares and operate multiple clusters of CNC servers. They also have big operational offensive capabilities, because they will find and exploit vulnerabilities in security solutions. And so we want to highlight here the need of applying the patches even to security solutions, so having a proper patch management policy. Also, if possible, have a network design that prevents the attacker from accessing the management servers. For example, by restricting the access to internal network only or users through a VPN, for example. So this also would be a nice move on the security side. So here is a list of the references of the different reports we listed in this presentation. So we hope you like this talk, and we hope to see you in person soon. Thanks.
Thank you very much, Daniel and Jaromir, for that presentation and for joining us live for your questions and answer session. Welcome to you both.
Oh, thank you. Nice to be here.
So, Jaromir, I wanted to ask you first. There are multiple threat actors using the toolkit Royal Road. So if there are multiple threat actors using the same toolkit, how can you tell which ones are related to Tonto and which are someone else?
Oh, that's true. So the Royal Road toolkit is used by several threat actors. We as researchers try to collect all the samples or the files. Then we have some automated tools, automated scripts to automatically get as much information as possible. And then after extracting the payloads, we try to match if we have seen this payload before, if it really belongs to this threat actor or someone else, or if there is maybe something shared, some shared CNC server or some shared infrastructure. So it's kind of combination of automation and like additional research.
How distinctive is the payload? How much does that give you certainty that you know it's Tonto?
If we have seen this kind of payload or very similar payload before, so it's like highly likely that it's from the same threat actor, or if it, for example, uses the same CNC control server, which we know has been operated by Tonto, so it's likely that it's still like another stage or another sample spread by them.
Okay, Daniel, I want to come to you next. You were saying there that there's been a lot of activity in a 5-month period. I don't know if that's the last 5 months because I'm not quite sure when you did that presentation, but in a recent 5-month period. But Tonto's over a decade old. So is that part of an upward level of activity, or does it go in phases? What have you noticed about the behavior?
Yeah, what's interesting about their activity, more than the amount of activity, would be more the targeting that has changed. So previously on previous reports, like very few countries were targeted, like Russia, Korea. Now we have seen a wider targeting, even European countries, for example, are targeted. So this would be the change that happened for Tonto threat actor.
And that was in that 5-month period?
They might have started before, but yeah, it's these few months. Yeah, no, not for a very long time.
That's interesting because it's been around for a decade and it's stuck to familiar territory for nearly all of that time. Do you have any clue? Are there some extra influences coming in behind the scenes, influencing where they go next, maybe?
We don't really have this kind of information, but they will also seen they changed their toolkits. They added some malware families that are shared with other threat actors. So maybe on the behind the scenes, other operators have joined the team, maybe something similar like that could happen.
It sounds like there could be a broadening of experience on the, I don't want to call it the Tonto team, but I guess there is a Tonto team, right? Having done the same or similar things for so long and now just suddenly being so different. So it sounds like it's well worth one keeping an eye on. Thank you both for joining us in the live Q&A. Let me just check that we haven't got any more questions coming in right now. But if you could jump into the chat for us, that would be absolutely fantastic, and carry on the discussion in there. That would be great. Thank you very much indeed.
Sure, thanks a lot for the conference.
Thank you.
Great to have you back again. Hopefully see you at another VB conference. So we have another presentation now, but just before that, I need to give you a quick update. Firstly, on the VB2021 conference. By the way, I decided to be less subtle with the memorabilia as we go through. Again, it's not necessarily a clue, could be a decoy, but there you go. Jeanette thinks it might be going to Edinburgh next. Bovsky thinks it is Dublin next. And Eddie says, wherever it goes, I will be there. Oh, thank you, Eddie. The Mugtion. Okay, you have only 45 minutes to get your bids in for this mug. It's very good. Just test driving it. I will wash it before we send it. We had $128 from Lucas. He was kind of implying that if he bid 128, the next one would have to be 256, which didn't happen. But then Paul stepped in with $150 if we all, the whole crew, and there's a smashing crew just next door there, put the signatures on it. And then Veronica has come back with $155. So there you go. You have now, 45 minutes tops to get your bids in. So we are going now to another presentation, and this one is XDSpy, Stealing Government Secrets Since 2011. And that is by Mathieu Fau and Frances Labelle, who's the co-author.
Hello, thanks for being here, virtually of course. I hope you're all excited to hear about a previously unknown APT group that has been stealing government secrets since at least 2011. I did this research with Frances Labelle, who was an intern at ESET at the beginning of the year, and he helped me analyze some of the malware sample I will talk about today. I'm Mathieu Fau, a malware researcher at ESET. My day-to-day job is to track APT groups in our telemetry. In the past few years, I mostly work on Turla and the Dukes, which is also known as APT29. If you are not already aware, we publish all of our research, including blog posts and white papers, on our blog, welivesecurity.com/research. So go check it out. The agenda for today? First, I will talk about the XDSpy group that is behind the campaign I will talk about today. Then we'll go technical with the analysis of the compromised vectors and the malware components. And finally, we'll end with a conclusion. So XDSpy, 3 reasons why it is interesting, and the third one will surprise you. First, this APT has been left undocumented from nearly 9 years until February 2020, when the Belarusian CERT published an advisory. And they included some network indicators, and that's how I was able to find this report and make the link with the research I was doing. But perhaps the most interesting part of their advisory is the list of targets in Belarus. It's quite uncommon to have such comprehensive list. And this kind of information is very helpful to fill the gap between the reality and what we see in the telemetry on VirusTotal. So for example, they say that several ministries, including the Ministry of Economics, Finance, Industry and Information, was targeted by the phishing campaigns of XDSpy. Then, the targeting is very unusual. So according to our telemetry, there were 5 different countries that were targeted by XDSpy in the last few years. So maybe there are more, but this is how I'm sure about. So first Russia, then Belarus, Ukraine, Moldova, and Serbia. And regarding the vertical, it's mostly militaries, governments, including diplomats, academics, and private companies. So for example, one of the targets was working in the metal recycling company, which is not the kind of company that is very strategic. So I'm wondering if the group is really targeting the company or if it was targeting a specific person that happens to work in that company. So the company might be more or less relevant. And the third reason is that some malware development choices attracted our curiosity. So this is some strings that I found in XDUpload, which is one of the plugins which is responsible for exfiltrating files from the victim machine to the CNC server. And as you can see, there are some paths of the file to be exfiltrated that are hard-coded directly in the sample. And Hence, we can find the username of the victim. In that case, the username of the victim for that sample that was uploaded on VirusTotal is InvisiMole. And I believe it's some Russian military unit. For the timeline, the oldest sample I'm aware of was uploaded on VirusTotal in August 2011. According to the PE timestamp, it was compiled a month before, in July 2011. It's possible that the group was active before, but this is the oldest sample I found, and in our telemetry I didn't find any activity before 2013. Then, during almost 9 years, they were active during cyber espionage operation and compromising high-profile victims. Then, in January this year, we started our investigation, and a month after, the Belarusian CERT published the advisory I talked about before. Then, for nearly 4 months, they were inactive, probably a COVID-19 pause, before coming back at the end of June 2020, with a new phishing campaign in which they use a pretty recent vulnerability. Attribution, this is a question everybody is asking every time for every new research. So in that case, the developers or the operators didn't leave any attribution clues. So it seems they are quite careful. But given the targeting and the goal, which is stealing documents or mailboxes from high-profile victims in several governments that I've shown before, I believe it's a likely state-sponsored group. So they are into cyber espionage, not cybercrime. So now let's go technical with the compromise vector. This group is into phishing. Only phishing. In the last year, it was the main point of entry they used. If we do some malware archaeology on VirusTotal, we can find this sample that it's from 2015, and it was sent to an employee of the Russian Ministry of Digital Development, Communication and Mass Media. There is an attachment, a zip archive, and in the zip archive there is a PowerPoint presentation. This decoy document is about some fire safety certificates, but what is interesting is that in the background there is some JavaScript code that is executed and that will download another component we call XDDON, which is like the main malware component used by XDSpy. Another spear phishing email that was sent in February 2020. The email asks the user to click on the link to download a letter on photographs related to work. This is short and sweet, but probably enough to trick people used to receive archive and documents all day long. So if the user clicks on the link, it will land on a web page controlled by the attacker. So the domain is controlled by the attacker, and this is a JavaScript code that is executed by the page. So it will trigger a file prompt to download a zip archive called photo 1102.2020.zip. And if the user downloads the archive, then extract it, you can see there is a .lnk file inside this zip archive, so only a .lnk file, no decoy document. This LNK file, so the characteristic of this file, there is no timestamp, but there is the account SID of the account that created the LNK file, so it was probably the account SID of the operator or developer of the LNK, but unfortunately I wasn't able to pivot on it. I didn't find any other sample. And the LNK file will execute some additional JavaScript code downloaded from filedownload.email, which is another CNC server of XDSpy. Unfortunately, we were not able to recover the script downloaded by the LNK, but we did see in our telemetry that shortly after the LNK execution, so every time XDDON, the main malware component, was dropped on disk. So it's likely that the script downloaded and executed by the LNK is just like a dropper for XDDON. In February 2020, one of the spearphishing campaigns unexpectedly turned into a disinformation campaign. So this is a printed copy of a spearphishing email sent by XDSpy. The sender was so the email address that sent the email, we found it in the Evasion search report. That's how we made the link to XDSpy. This email states that the first cases of COVID-19 were discovered in Belarus, but the problem is that this spearphishing email was sent before the Belarusian government acknowledged the first cases. So people started to share this printed copy, this photo of a printed copy of spearphishing email on many social networks as a proof that there were COVID-19 cases in Belarus, while it was just a XDSpy spearphishing email. So that's kind of funny. Then, for nearly 4 months, the group was totally inactive, or at least they didn't run any spearphishing campaign. I was wondering if it was possible to map this information with the lockdown in a country to determine the origin of the attacker. Unfortunately, I spent some time searching that, and I was not able to reach any conclusion. Then at the end of June 2020, they made a comeback with a spearphishing campaign that started the 29th. And the TTPs are quite similar. Zip archive, so this time it was an attachment, not a link. The zip archive contains a RTF file. And this is an example of one of the decoy documents. So it's still in Russian. And this RTF file has a OLE link object, so the RTF will download additional contents from a CNC server, minisnowhere.com. As the data returned by minisnowhere.com is HTML content, it will be rendered by the Internet Explorer engine, even if the RTF file was open in Microsoft Word. If we take a look at this HTML file, so first, it starts by setting the compatibility mode to Internet Explorer 8. So this is the first suspicious thing. Then there is some JavaScript code. If we scroll down a bit, we can see there are multiple calls to collect garbage, again collect garbage. So this is the second suspicious thing. I'm not a pro JavaScript developer, but this is not something you see in every script. Then we scroll down again, and there is strings such as virtual protect, get module handle a, get proc address. So it definitely smells like the shellcode. And at the end of the script, there is a call to fuaf.exploit, where UAF stands for use after free. So yeah, I think we have a vulnerability. We have an exploit. And it looks familiar. In the past 2 years, there were 4 very similar use after free vulnerabilities that were discovered in the legacy Internet Explorer JavaScript engine. And because it was in the legacy engine, that's why they set the compatibility mode to Internet Explorer 8. So I didn't analyze these past campaigns, but there are a lot of public information about them, and apparently most of the exploits were used by Dark Hotel. You can see this analysis by the Japanese CERT, for example. Also, if you are interested in details about this vulnerability, I encourage you to check this presentation that Clément Lessing, who worked at Google Threat Analysis Group, made at the STIC conference. So the recording is in French, but you can check the slides as they are in English. And the next 3 slides are taken from his presentation. So the first vulnerability, as you can see on the snippet of code on the right, there is 3 calls to collect garbage. So this is very similar to what I've shown you just before. Then the one for 2019, there is again calls to collect garbage, but this time the vulnerability is triggered by a callback to the sort function. And actually the third one that was discovered at the beginning of 2020, it's very similar, almost identical to the one from 2019. But if we go back to the XDSpy exploit, the third vulnerability was patched in February 2020, but I tested the exploit with a machine patch with updates from February, and it was working. So what exactly is the exploit they use? If we go back to the code, we can see that the exploit is not triggered by a callback to the sort function, but by a concatenation of two strings E and D. So this is a different exploit. And it's actually CV2020-0968 that was patched in April 2020. XDSpy used this exploit at the end of June, beginning of July, so it was a one-day exploit. They exploited it 2 to 3 months after it was discovered and patched by Microsoft. But on the other end, there is no public POC available. So they didn't reuse some code that was available online. And the XDSpy exploit looked very similar to the previous exploits that were apparently used by Darkhotel. First, we don't believe XDSpy is linked to Darkhotel because the targeting is very different. Also, XDSpy malware components are not that sophisticated, so I'm not confident at all that XDSpy will be linked to Darkhotel. But it is possible that XDSpy bought the exploit from the same developer or same broker as Darkhotel. That would explain the similarity in the code. Or it's also possible that they found another group use this exploit and repurpose it, or that they develop this exploit variant from the three other exploits. But I don't believe they developed the exploit from the proof of concept that is available on GitHub, because the proof of concept was developed by someone else and it's very different from the exploit used by Darkhotel. So now we can jump to the malware components. This graphic is based on the compromise chain of February 2020 with the .lnk file. So after the .lnk file, it downloads xddawn from the CNC server. Then xddawn will download additional plugins such as xdrecon, xdlist, xdmonitor, and xdupload. Xddawn persists using the run key, so it's not really sophisticated. It's like a typical persistence method. The command control server and all the paths are hard-coded in the malware. The strings are obfuscated with Caesar cipher, so it's not state-of-the-art obfuscation, but it's enough to annoy us when it comes to write Yara rules. Xddawn capabilities, so it's strictly a downloader. It basically downloads and loads DLL. DLL, these are like the plugin I talked about before. Also, network communication are using HTTP, and the content is encrypted with a static XOR key. So, for example, this is some data retrieved from the CNC server, and this is the beginning of a P header. So you can imagine that the XOR key is obviously 3173. And it's the same XOR key in almost all samples. Finally, perhaps the most surprising, there is no backdoor capability. So every time the operator wants to do a specific action on the machine, they need to compile a new plugin, a new DLL with this specific action or specific functionality, and then push it to the victim machine using XDdawn. So at this stage, my main hypothesis is that they ask David Goodenough to write their malware components. Then the plugins, XDlist, XDmonitor, they will cross local drive, also monitor removal drive for interesting files. There is a list of interesting extensions. it's mainly documents such as doc, but also emails such as email or mailboxes. Then the interesting files will be reported to the CMC server. And at the next step, the victim will receive XDupload, which is one of the plugins that is responsible for exfiltrating the files. In that case, the files that need to be exfiltrated to the CMC server, the paths are hard-coded in the sample. So the operators, they are receiving a list of interesting files. Then they are compiling a new sample of XDupload with all the interesting files they want to get. In that case, there were 134 different files to be exfiltrated, and this path is an example of one of those files that will be exfiltrated. So it's a .ost file, so it's the full mailbox of the victim. Finally, the other components. There is XDRecon, which gathers basic machine information. This is the first plugin to be deployed on an infected machine. There is XDPass, which is a quite simple password stealer that will recover password in browsers. And finally, XDlock. This is a plugin that will gather the nearby SSID, I mean the nearby Wi-Fi access point. And my guess is that it's exfiltrated to the CMC server, but my guess is that it's used by the operators to locate the victim machines. So there are several services online where you can put nearby SSID and they will give you a pretty precise location of the machine. So as a conclusion, XDSpy is a previously unknown APT group that has been active for the past 9 years. Their malware architecture is quite unusual. I've shown you they are only a downloader, no backdoor, so they recompile and deliver new plugins every time they want to do something on the victim machine. Also, the path of the files that are going to be exfiltrated are hard-coded in the samples, so it allowed us to identify the victims, but also to check what they wanted to exfiltrate. On the other hand, they use a non-public one-day exploit. So even if their malware are not that sophisticated, they have the resources. Either they can buy exploit or they have in-house capability to develop exploit from non-vulnerabilities. Their main goal is to steal documents or mailboxes. So it's clear that the final goal of this group is only cyber espionage, and that it's probably sponsored by a state. I would like to thank Antti Tikkanen from Google Threat Analysis Group for the initial hints that helped me start this research. Thanks for your attention. Feel free to ask questions.
Thanks, Mathieu. And now he is joining us in the studio for live Q&A. Welcome to day 3 of VB 2020.
Hello, thank you.
Glad to have you on board the virtual conference. Obviously, you've presented at the physical conference in Denver as well. How's your virtual experience been?
It was quite different. Like, it's a bit difficult to record a talk alone in my office, but I know that it's the current pandemic doesn't allow us to be all together.
And as the pandemic's going to be around, it's a skill we all need, Mathieu, at the moment. Now, before I launch into the questions, a bit of an update, because I believe there's been a bit of news, hasn't there, about 4 days ago? What happened?
Yeah, so 4 days ago, the Belarusian CERT made a new advisory. So they made one in February, and they made another one 4 days ago. And in this new advisory, they were saying that there are new spear phishing campaigns against various organizations in Belarus. and the spear phishing email were using the theme of protest, like the protests that are currently happening in the country. They were using that as a lure to lure people to click on the malicious link. And in those emails, when they were specifically talking about the violence of the police in Belarus. So it shows that they're really using hot topics in order to compromise their targets.
And does that give you extra information every time you find what it is they're using to proliferate, to spread around rather? Does that give you more information about how they're operating and maybe what to expect next?
It gives us information about what are their main targets. So now it shows that they are very focused on Belarus. They are also focused on Russia, and these are the two countries that receive most of the spear phishing emails from the group. And it also allows us to better track their network infrastructure.
Okay, and can I, going back to the beginning, if you like, why did you dub the group XDSpy? Why the spy bit?
So spy because they are spying on their victim, and XD because since the beginning, so since the first version of the malware that was released in 2011, when the malware downloads additional plugins, they download the plugins in 3 different parts, and each URL ends with .xd1, .xd2, and .xd3, and that's why I decided to name the group that way.
Now, they've been around a long time, 2011 to what was looking like February 2020, we now know differently. They seem to have stayed pretty much under the radar all that time. How are they managing that?
So first, I think that the malware are quite basic, so it doesn't raise a lot of suspicion first when you look at it. So they put a lot of effort on the obfuscation side in order to evade security solutions. But the malware code in itself, it's not that complicated. It's not like state-of-the-art code like you can find like in Equation Group or some other well-known APTs. So maybe it didn't attract a lot of attention from researchers. And also the targets, they're mainly targeting Russia and Belarus. I believe these are not the countries where most security companies have visibility. So that might explain why people didn't look at that group.
And by keeping it simple and maybe acting cautiously, is that giving them the longevity so that they can just carry on?
Yeah, and I think they made the mistake by using one-day vulnerability in June because it attracted attention on them, because this vulnerability was not exploited in the wild before, and they were the first to exploit it. So people started looking at the group because of that use of a one-day vulnerability.
And when was that? When they start doing that?
So they use a one-day vulnerability at the end of June.
Yeah. This year.
This year, yeah.
Yeah.
And this vulnerability was patched in April, but between April and end of June, we don't have there was no other group exploiting this vulnerability in the wild. So people were trying to find a group that was exploiting the vulnerability, and when they were caught using that, people started looking at their malware, their network infrastructure, etc.
Maybe their cautious strategy was the way to go.
Yeah.
Matthew, thank you so much for joining us. Do jump into the Q&A chat and the general chat and carry on the conversation in there. But for now, thanks very much for joining us.
Thank you.
There we go, another fantastic presentation there at VB2020. We have another break right now, but During the break, remember, you only have a few minutes left to bid for this fabulous mug and raise money for the Land Trust. So head to the Mugtion chat if you want to bid on that. I think it is still standing with Veronica at $155, although apparently her husband is freaking out about that. Sorry, Veronica's husband, but it's a lovely mug. What can I say? The VB conference guesses, we've had another guess of Gnome Goose saying New Orleans. That could happen. And we've got another possible clue or possible decoy here. So keep those guesses coming, because there's not much more time now until we reveal the final outcome. Remember that you can still chat, you can still look at the on-demand, you can still have a look at the live from day 1 and day 2, although do remember we are back here at 1900 UTC for InvisiMole. And just before I take a break as well and join you, I just wanted to say, I know I'm a newbie and I've never heard the bell rung to get you back from coffee. There's a lot of us newbies around this year. I'm doing my best, but I need some guidance. So I have tried the little bell. I've tried segueing with the big bell. I have tried the Vibra Slap, and I haven't even tried these yet. But something tells me they're just not what you want. So I am going to do my utmost to get the bell to bring you back from this break. Wish me luck. see, that's how it's done. Now I know. Now I feel initiated into the Virus Bulletin Conference family. Now I've had the bell, not just that bell rang at me, but rang by Karen. So thank you very much, Karen, for showing me how that's done. And my search has now ended. Thank you. Now we've had some questions about the photos on the shelves behind me, so I might just chat you through those in the next session. But for now, we're going to hear about InvisiMole, first-class persistence through second-class exploits, and that's Susanna Romkova.
Hello everyone, thank you for tuning in for this presentation. My name is Susanna and I work for ESET as a malware researcher. And today I'd like to discuss a piece of research that I was working on together with my colleague, Anton Cherepano, who led the investigation in our ESET research lab. Today's presentation will revolve a lot around exploits, but before we go any further, I'd like to start with a quick thought exercise. So, when I say exploits used by the attackers in the wild, what's the first thing that pops in your head? Probably some cool 0 days, right? So, maybe you're thinking Turla or Stuxnet or Evasion using 0-day exploits for their operations. Well, let's stay in this category of these sophisticated threat actors who know what they're doing. And let's imagine you're one of those and you want to spy on some victim. What would be your weapon of choice? Say you found some vulnerability in a Windows XP library. Would you choose that one? Or maybe you'd rather go for an outdated video player with a Stack Overflow vulnerability? Or maybe some driver exploit known for over a decade now. The question is, would really experienced threat actors even consider using any of these old vulnerabilities? We would say no, right? But that's exactly where we would be wrong. See, in this presentation, I will show you a case of a threat actor who is by no means inexperienced, but still took these free archaic vulnerabilities and pulled off some first-class persistence. So, hopefully, by the end of this talk, you will care much more about Windows XP vulnerabilities, and more. But let's start from the beginning. Let's see what this spyware InvisiMole is about. So InvisiMole is a highly targeted spyware, focusing on high-profile organizations in Eastern Europe. This includes military organizations and diplomatic missions. We first reported on InvisiMole in 2018 and then reconstructed their operations all the way back to 2013, back to the first known instances of InvisiMole. In 2018, we analyzed their 2 backdoors with their rich espionage capabilities. But we didn't have the further context, so we didn't know the rest of the group's TTPs. That changed late last year when the group resurfaced with an updated toolset, now much more important and interesting than those 2 backdoors. We started our investigation, and thanks to the cooperation with the affected organizations, we were able to do a forensic analysis and reconstruct the full compromise chain. What's more, we also revealed a cooperation between InvisiMole and another threat actor, Gamma Radon Group. This will be also important for our story today, so let me just do a quick overview of this strategic cooperation. You probably already know the Gamma Radon Group. It's a threat actor which is highly active in the Eastern European region, just like InvisiMole. It's not really sophisticated, but it has been active for at least 70 years now, and it has attracted attention of fellow security researchers during that time. But this is the first time that this cooperation is revealed. So what is the role of Gamma Radon in this cooperation? Well, the group is responsible for breaching the target organizations. And of course, it's also doing some basic fingerprinting. This group is known to be spread using malicious spear phishing emails with malicious documents with macros, which install one of the group's downloaders. Then it gets a bit blurry, because these downloaders could do a lot of things. They could download a variety of tools for reconnaissance, for privilege escalation, you name it. But what we do know is that at some point this .NET downloader by Gamaredon is delivering a bundle with InvisiMole's payload. So in this case, InvisiMole's TCP downloader. So in this way, the victim gets upgraded from Gamaredon to a much more advanced payload, InvisiMole. And according to our investigation, this doesn't happen for all the Gamaredon's targets, just a small number of them, so probably those deemed particularly interesting by Gamaredon. Well, what's important to remember for today's story is that whenever InvisiMole is starting their malicious operations, they're already operating from within the network, and in some cases they're also already elevated, as we have seen. So back to the main story, the exploits. Another question I want to ask is the motivation of the attackers. Why are they using the exploits? Now, regardless of the actual exploitation techniques they're using, whether it's heap spraying or rob chain, why is it that they're exploiting these vulnerabilities? What's the main goal? In other words, what's the part of the cyber attack lifecycle in which this exploitation occurs? We know one of the scenarios is an attacker which is operating from outside the network trying to get in, so exploitation for access. Then in another scenario, the attackers are trying to get privileges, so they're exploiting the vulnerabilities for privilege escalation. But what happens if the attacker is already in the network and already elevated, just like is the case of InvisiMole? Well, the attackers can still go one step further and exploit a vulnerability to gain invisibility. Now, the main difference between these scenarios is that in these two cases, the attackers have to rely on the victim already being vulnerable. So they're either using 0 days or they're using some older vulnerabilities, but in this case, the victim must have forgotten to update, or the attackers must rely on the victim not having updated the newest version of the OS or the software. And in this case, it's a different story because the attackers are already operating from within the network. So they're able to bring any vulnerabilities to the system that they want. So first they introduce these vulnerabilities and then they exploit them for covert code execution and long-term persistence. And this is what InvisiMole is doing. So today we are not going to cover RC or LPE, but we will discuss this specific case where the attackers are exploiting a vulnerability to get invisibility. And now this motivation is similar to what attackers are using, or what they are trying to do, but they're using the living of the land technique. So with living of the land, in general, the attackers are abusing some pre-installed legitimate tools on the system to carry out their malicious operations for them. And that's a similar scenario here. InvisiMole has the same end goal. It's just using a different set of tools. For them, living of the land binaries are just the starting point. They're also using a couple of those legitimate tools which are already on the system, but they're also bringing a whole much more legitimate tools with them because they prefer to bring their own arsenal to the system. So we have seen them bringing other legitimate tools to the system along with a vulnerable driver and vulnerable user mode executables. And then all of these legitimate tools are combined with InvisiMole's payload to create 4 elaborate persistence methods. And each of these is designed for a different type of victim's environment. Now, you don't have to study these chains in detail. What's important to notice here is that they are using the same strategy regardless of the type of victim's environment. So regardless of which of these chains will be used on the victim's computer, it's the same strategy over and over again. So they exclusively install legitimate tools, and then the malicious code is only loaded later. It's always encrypted on the computer and is loaded by these legitimate tools. Sometimes they're abused, sometimes they're exploited. You can see here, in this chain, it's the vulnerable video player which is exploited to decrypt and load InvisiMole's payload. Then in this chain, the vulnerable driver is exploited so that InvisiMole can inject its malicious payload to a trusted user mode process, but they're using this from the kernel mode, which is more seamless. But what I want to actually discuss today, and in detail, is this chain, because this one is used against the newest OS version, so including Windows 10. And it's used in cases where the attackers were able to gain administrative privileges on the system. So in those cases, they will be using this particular chain for their victims to set up persistence. And this is the chain where they are actually using the vulnerable Windows XP library brought to the system by the attackers. So let's look further and let's understand why they are using a Windows XP library on Windows 10 computers. We're not going to cover how the attackers are setting up this chain, so we are skipping the whole installation phase here. But we're going to look at what actually happens when the user already turns on the computer with this persistence method installed. Well, in the next couple of slides, I will look at the technical details, but bear with me. It's important to know how exactly this chain works so that we are able to understand why this Windows XP vulnerable library was used. So let's dig deeper. So when this computer is started, this chain starts with a scheduled task with this specification. And this task is doing two things. First, it creates a folder with a specific name, and then it executes a file called setupsnkey.exe. And this is a copy of a legitimate Windows component brought to the system by the attackers. It's a wireless network setup wizard, but that's not really important. The important part is that this executable is designed to load a specific DLL. Normally, the DLL is hard-coded, but this component also allows the option of defining your own custom DLL. It's an undocumented feature, but InvisiMole is using it as its stage number 1. So they're creating that folder by the scheduled task just to force a specific execution path through this executable, which makes it look for this customly set DLL in the registry. So they're reading this registry value and using the value to build a command line which will later be executed. So indeed, InvisiMole is setting that registry value to this string, which makes it build this command line, and then that one is executed by setupsnkey.exe with the create process API. So what actually gets executed is vdigest.dll, which is again a copy of another Windows component. This time it's a Windows XP library. You can see over here that this library is loaded by rundll32.exe. This is also a Windows XP version of this executable, so it's also brought to the system by the attackers to make the whole chain work. The important part is that this library has an input validation vulnerability, and that's why InvisiMole is using it as stage 2, because it allows it to pass shellcode bytes as command line parameters. And when this library is loaded with these parameters, then the shellcode rewrites one of the global variables called LSE functions. And this variable is later used to determine which functions should be called, so later in the code. And because it's rewritten, it will actually read an address from the shellcode, so provided by the attackers. And this address from the shellcode is actually pointing back to the Windows XP library. As you can see, the addresses match. How is this possible? Well, remember it's a Windows XP library. There was no ASLR at that time, so the attackers will know at which addresses this library will get loaded. So in this way, they are able to use their instructions or even their imports directly because they will know precisely at which addresses these parts of the code will be loaded. So in this case, it's a jump instruction which jumps back to the shellcode. But this is how it continues. The execution goes from the shellcode back to the library and back, and this repeats until the stage 3 is loaded. And the stage 3 could already be any executable, right? Because the exploitation phase is over. But this is not what happens here. InvisiMole is actually continuing to use these code gadgets from the vdigest DLL library and lives off these code gadgets instead of writing the code by themselves in the shellcode loader. And why are they doing this? Well, exploit writers commonly use code gadgets, right? But normally they're using it for a different reason, to exploit the application and to get somewhere, to get to the system, or a different type of exploit. But InvisiMole has a different motivation. They're trying to minimize the amount of malicious code which is brought to the system by the attackers. So in this way, this component can completely rely on the Windows library and the code which is already in there, and just to take the pieces from the library and create whatever they are trying to accomplish, which is to load the next stage. And if you look here, the next stage is already encrypted, and so is the rest of the execution chain here. So we can stop and look at what this chain looks like. The first two stages are legitimate Windows components, and then there is this exploit and a shellcode loader, which are both using code gadgets from the library. So without knowing the context, it's really difficult to say that those two components are actually malicious. And then, because the rest of the chain is encrypted, this makes it really tricky to detect that something fishy is going on. But back to the encryption, what the attackers are using for encryption is so-called Data Protection API, or DPAPI, which is a standard Windows feature to protect passwords or cookies, and it features a function called crypt protect data, and that encrypts data in a way that they can only be decrypted on the same computer when they were encrypted. So InvisiMole is actually using this function in some earlier phase when this chain and the other chains are being set up. So all the malicious components will be actually encrypted with this function and later decrypted with its counterpart, crypt unprotect data, with one of the InvisiMole's loaders. And this is a smart move because now the components which are encrypted, even if the AVs are able to collect them, or the security researchers are able to obtain them, they're not able to decrypt and analyze them. We're only able to decrypt and analyze these components because we were already in contact with the affected organizations. So we were able to get back to the computers where these components were actually encrypted and then decrypt them and analyze. But it would be tricky without this cooperation. So what happens under the hood of this next stage? Well, this is a user mode inject. So the goal of stage 4 is to inject stage 5 under a legitimate Windows process. And it uses a technique called list planting, which is a type of a window message-based injection. This type of injection technique uses a control called list view, and uses the fact that you can define your own callback to sort list view items. And the communication between the malicious process and this target process is done via window messages, so that's the name window message-based injection. So in this way, InvisiMole is able to copy the malicious code of the next stage to the target process and then trigger its execution. Now, there's much more to this technique, which is pretty rare and I think interesting. So if you're interested in more details, please read the paper. For the purposes of this story, the only part which is important is that the goal of this user mode inject is to get the next stage to a trusted Windows process. And then this next stage is ultimately loading the final payload from within this process, which is InvisiMole's backdoor and DNS downloader, using DNS tunneling for CNC communication. And so this is the whole chain in a nutshell. This is how it works. This is how the attackers designed it and what will happen when you turn on the computer. But now let's go to the main part to understand why they designed it this way. And for that, maybe it would be better to look at it from the point of view of an administrator or a security monitoring operator who are trying to understand what's happening in their computer, in their network. So if you look at the process tree, what's actually going to run on this computer during this chain, we'll see that all of these processes are legitimate Windows processes running from legitimate Windows executables. So this chain starts with a scheduled task, then there is this legitimate Windows component, and then this Windows library gets loaded. Yes, there are these two exploits using these code gadgets, but it's all under the same process. And then the last part of the chain is injected again in some trusted process. So if you look at the process tree, you will probably not see anything suspicious. What about the artifacts left on the system by this chain? Well, that's similar. There's, of course, again, this scheduled task, which shouldn't be there, but it's only scheduling some legitimate applications, so not sure if that would be suspicious. Then, of course, there are a couple of legitimate executables, so that's benign, of course. And when we look at the back of the chain, there are some malicious components, but they're all encrypted and all in the registry. So again, not so easy to detect. The only part of the chain which is not strictly legitimate and not encrypted is these two values in the registry, the exploit and the shellcode loader. But as we know, these are using code gadgets from the Windows XP library, so again, not so easy to say that this code is malicious. What I'm trying to say is that this combination of legitimate tools with vulnerable legitimate executables makes it really tricky to detect that something fishy is going on if the security solution missed the installation phase. And we cannot pretend that doesn't happen, right? There are many reasons why an AV could miss the initial phase of the attack. For example, because of some AV bypass trick, or maybe because the attackers have physical access and were able to disable the AV. Nevertheless, we are still wanting to look at what happened and want to be able to reconstruct the full chain, not just to know that something is going on, but also to look at all the stages. And in this way, it gets really tricky to do that. And there's also the other question of how you actually remove this thread, even if you know what is going on. Remember, this chain features a lot of legitimate tools and vulnerable executables, which are, by the way, legitimate as well. So the issue is that there are users which could legitimately use the same vulnerable executables. For example, that video player or even the Windows XP library, why not? So we cannot just simply delete these files by hashes, even if we know that they are misused in some execution chains for malicious activities. So again, there are some more advanced methods for removal needed in this case as well. And now, if you ask me if this is a new technique, well, we all know that there were some cases in the past, and probably now as well, where the APTs used vulnerable drivers, brought to the system and exploited them to load their own malicious drivers. Turla or Slingshot APT, just a few. And this is something else. InvisiMole is also using a vulnerable driver, but also a pair of vulnerable user mode applications. And they're using it in a way just like they would be with a lolbin. So they're combining all of these to create these long execution chains to gain covered code execution and long-term persistence. So they're not doing that to load their malicious drivers, but they're using it as a general strategy to avoid detection. But if you ask me if there is more, well, yes, there are still some unexplored options which could be incorporated as well. For example, these two papers in the academic sector, there have been some cases in these two papers where the researchers actually wrote these vulnerable applications by themselves. So not like InvisiMole, which is using some already vulnerable executables, but in this case, the researchers wrote their own vulnerable applications to bypass Apple and Google Store security protections and get their applications in there. And then once the applications were on the user's device, then they were able to remotely exploit these applications and change their behavior from legitimate to malicious. And this is a different case, a different scenario, and definitely a different motivation of why these researchers did this. But since we are on this topic, I thought it would be interesting to mention this because when these two approaches would be combined, it would be again a twist on what InvisiMole is already doing with these vulnerable applications. So just imagine that we already are blacklisting all known vulnerable applications and are responding to them in some way in terms of detection. But then what stops the attackers from writing their own vulnerable applications and then exploiting them themselves? Again, another layer that we would have to think about. Anyway, what this case shows us is that when the attackers are operating from within the network and possibly elevated, then they can go to any lengths to hide their malicious payload, in this case by misusing legitimate but vulnerable applications for covert code execution. And that brings me back to these guys. See, we wouldn't think that these free vulnerabilities are necessarily serious in these days, because the attackers didn't get anything that they didn't already have. They didn't gain any new access or privileges. But I would still argue they're pretty serious still, because the attackers were able to gain invisibility, and with that they were able to interfere with what should be our main goal, and that's putting a stop to their malicious operations. So of course we should be still hunting for 0 days used in the wild. We should still be making sure that all's patched and all is updated. But I think we should also be looking out for these older vulnerabilities and older versions of now patched software, because when they are misused in this way, they can still get pretty serious. With this, I thank you for your attention, and if you have any questions, I invite you to read our full white paper. Or better yet, go ahead and submit your question for the live Q&A right now. Thank you very much.
Thank you, Susanna. Yes, get your questions in for the live Q&A right now. Get typing, because Susanna is with us for the Q&A session. Welcome to VB2020.
Hello.
Hi. Now, you're no stranger to the Virus Bulletin conference because you presented last year, I believe, in the physical conference. So how's your online experience this year?
It's very different, but I like it. It's running smoothly and professionally, and the talks are really interesting. So thank you for doing this.
I'm glad to hear you're enjoying it. Now, this is aptly named InvisiMole because it's virtually invisible and very, very difficult to track down. You compared what this does with where the attacker brings vulnerable software to the infected system with where the attacker just uses software that's already on the system. But is that really that different? And is there any other difference between the two cases?
Yes, so when we are talking about this traditional scenario, the attackers are using these living off the land binaries. These are usually some admin tools. And this is a different scenario because they're choosing a different tooling set, is these vulnerable applications. And there are some differences. The obvious one is that with these vulnerable applications, you have broader options for the functionality because some of them are not supported by these pre-installed admin tools. But maybe the most important difference is that this scenario is new and it's not expected. So with these lol bins, they've been misused this way for a long time now. So the defenders already reflected this in their EDR rules, in their detection strategies, but we are not expecting vulnerable applications being misused in this way. You probably wouldn't block a vulnerable application because it's legitimate. But now we have to look at the context in which it's used on. We have to be able to detect that it's being exploited and run by the malware. So this is the main difference, that they are using this because it's unexpected. It's a new move to surprise the defenders. So maybe if you ask me this in a year, the question would be there is not really a difference because by then we would have updated all these tools and all our detection strategies. But right now it's a new trend, so that's the main difference why they're using it. So yes, there is a difference.
And one to keep an eye on. So from the attacker's point of view, is there any benefit in exploiting old applications instead of new ones using this technique? Or is using old vulnerabilities just in this case a coincidence?
So they had some, InvisiMole had some advantage of using these old exploits when compared to some new exploits, because in this way, from the example with the vulnerable Windows XP library, there was no ASLR, so they didn't have to run ROP chains. They just created these, they used these code chains, so it was easier for them to write these exploits. But if we look at it from the overview, it's not really important whether it's an old exploit or a new exploit. The important part is that they're using vulnerable applications instead of lolbeans. So they're exploiting some applications instead of misusing some system tools. So it doesn't really matter whether these are new or old exploits. So this could even be some applications with 0 days used in the future. So in this case, there were some advantages for them, but the technique is much broader. So it could be misused in any other ways.
Okay, thank you. Now there's a question just in from Alexander. Can you please shed light on the targets of Gamma-Read and InvisiMole groups, so the targeting?
So as we said, it's the Eastern European region, especially high-profile organizations. So it's military, diplomatic entities, but we cannot go any further.
Great, thank you very much indeed. Thanks for joining us, Susanna. Can you join in everybody in the chat, in the Q&A, because we've just had that question in and there may be more. So if you could jump into the chat for us, that would be fantastic.
Will do, thank you very much.
Thank you very much for joining us. And so we only have one speaker left on VB2020. But just before I introduce that last presentation, I did promise you a little walk down memory lane. And I've got the photos off the shelves because it's easier to see. So first of all, we have this one. This is a photo of Veselin Bontchev, one of the great names of the AV industry. And this was taken at VB92. So that was the second Virus Bulletin conference. And that was in Edinburgh. Somebody said earlier they didn't realize it had ever been to Edinburgh because they've been coming to a lot of these, but that was just a little bit too far back for them to remember. This one is a photo of all the speakers at the first ever Virus Bulletin conference in Jersey in 1991. And we won't mention the fire. There's a lot of stories for the VB conference. We'll have to save those for another time. And on the far side over there is a very recent one, so VB 2017, and that was in Madrid, and that's a photograph of all the speakers there as well. So a little walk down memory lane for some of you there. The mug is no longer mine, but I'll tell you who it does belong to after the next speaker. There might be some clues around as to where VB 2021 is going to be as well. But first, we have our last VB 2020 presentation. And it's Clippy Left Some Traces by Christian Beek.
Hello, and welcome to this presentation. Clippy Left Some Traces. Of course, you know Clippy from the early days in the office suite, and I used it as a kind of practical joke to focus more on the forensic analysis on office files. I would say in the daily practice, we tend to really focus mostly on the macros, or if there's some other time stamping and things like being done in the office files. But from my forensic background, I believe there was a lot of more traces possibly that can help doing our research into these office files, and maybe reveal more about the campaign or the adversary behind the campaign. So in this presentation, I'm going to walk you through some of these formats and also the things we're going to look at. My name is Christian Beek. I'm a senior principal engineer lead scientist in McAfee's Advanced Threat Research team. The Advanced Threat Research team in McAfee consists actually of two branches. One of them is actually the vulnerability research of the house. They're looking at IoT devices, for example, or facial recognition, manipulation. things like that. And in the other side of the house, we do a lot of research on nation-state campaigns, cybercrime campaigns, and where we learn about those campaigns and what we apply in maybe some new innovation, maybe some new techniques we want to cover. So a lot of things we're doing on a daily basis. And if you like to follow me, I try to tweet frequently on this Twitter account. And of course, no presentation on Clippy without Clippy. So there he is, and probably we'll see him more during the presentation. So this is kind of the structure of the presentation. So first I'm going to talk about the older formats, the compound file binary. We do some campaign examples. And next we will focus on the more modern formats being used by Microsoft Office. And then we're digging into a campaign where I will highlight some of the findings and discoveries we did digging into those campaigns. Yes, Clippy, you're absolutely correct. I forgot the agenda, but you know what? Let's move on. So Microsoft's compound file binary format. It's actually a kind of file format where it stores objects and streams in a hierarchical structure and actually within a single file. So if you remember the FAT file system, and if you're into forensics, file system forensics book by Brian Carrier is a must. So if you haven't read that one and you want to go into forensics, please read that book. And it really describes as well the file FAT system. So if you look at the system here, the compound file binary, it will always start with the magical header starting with D0CF, as you can see in my slide. And mostly when we talk about the Office files used and having this format, it's the doc file, the XLS file, and the PowerPoint file. So, of course, OLE tools is, I would say, a must when you are actually researching Office files. So one of the basic tools I'm always using is like, if I have a file or like a doc or Excel or something like that, I'm using this to look at, okay, give me the summary about this document, for example. And as you can see here on the right side in my slide, it gives some what we call metadata and information for the streams. So you can see here that there was a template used called normal. It was last saved by a user account by the name of user. You see the last printed, the create time, save time, and some other artifacts that are present here in this document. And of course, as Clippy mentioned correctly here, is that metadata can be manipulated. So the fact that it is present in a document is nice to know, but always take in consideration the data could be manipulated. But still, if you look at these fields, there are some valuable fields here and here which can be very useful in your research. So one of the things you need to remember is that the timestamps are always in UTC. So if you have a lot of documents from the same actor and you can translate that time zones and you say like, hey, and you have a hunch of which direction you think this campaign is coming from, translating those time zones into the time zone timestamps you think the adversary is operating could reveal, for example, office working hours. We have seen that a couple of times before. If you look at the print date, it's not only the print date when the document was sent to a printer, but also if you do like print to PDF, that's the same timestamp. So it will record that timestamp when you printed the document to a PDF document. And the total edit time here is actually how long the document was open. So not, keep in mind, when it was actively edited. That's not what it says. Yeah, that was a good forensic tip. Thank you. So I think another interesting fact on compound file binary is that if you look at a document, for example, with a tool called Structured Storage Viewer, you can actually see really nice those streams and the different objects in the document. And one of the subfiles here is called document summary information. And when you look at some of this, the value, which is called GTK, I can even pronounce that, but you see it here on my screen. There's a value over there. And that will help you actually verify the Office version in this document, where Of course, it can always be manipulated, but in this case, when you look to this file, I could actually get out this file 0x10, which is 16, and we can say that in this particular file, Office 2016 was used by the creator of this document. Another really interesting thing is that in the same compound file binary, and if you look at the file structure and you use the same document summary information or summary information, you actually can discover the operating system as well that was used by the adversary or the creator of the document. So if you look at this document and you look at these values here, you see it starts with FEFF, but then you go a few bytes down the line. There's where the 4-byte property set system identifier is actually set. And it will show you the major and minor version of the operating system. So in this case, you would see 06010200. So if you look up those values and by Microsoft, you would actually notice that Windows 7 was being used. So here's already we have 2 bits of information, right? It's Word, we have Windows 7 being used, and we have Office 2016 being used to create this document. So let's dig into an example of a campaign. So this is a campaign which we saw used by VB2020, and yes, again, yes, Clippy, you're right, thank you. When we look at some of the file names and artifacts here, you see already like a file name, sounds a bit like a Russian, right? And we see that it's a Word file, it's not encrypted, it has some VBA macros, and it's a Word document. On the right side, again, we have the metadata and creation time, last save time. You see already that there's a kind of difference, like almost more than a day in there. We see a revision number of 25, and we also see a total edit time of 2C640. So all interesting artifacts that we can take in consideration. Of course, the author is user. We see that in the last save by user. So some of the artifacts that can be very useful here as well. Now, if I use all tools as well, this is actually an overview of the file structure, the streams and the objects. And this is like very interesting to me as well, where I can see the root entry, the streams, the sizes, where if there's a parent-child, how the construction is focused. But here you can see as well, of course, we see number 6 here, ID 6, storage macros, and number 7, storage VBA. And then at number 9 and number 12, we see like a suspicious name, right? Like there's something there that's very suspicious and something that might be interesting to look at. So definitely there's some macro code here that needs some investigation. Also, if you use the output from Ollie, there's this modified and creation times overview of those different streams. And as you can see here, the macros and VBA time, creation time, so C time, and modification time, M time, it follows the actually creation and modification timestamps of the overall document. And as you can see here lower in my screen, you also see that suspicious name of the macro code here being used. Again, we looked at the system information over here from this document. And what we noticed in this particular one is that major minor version of the OS, we had these values 0602, and we could say that this document was created on a Windows 8 machine. So not very often seen, so definitely a nice indicator as well. So that was actually about that file format, and now we're moving into the OOXML format. And actually, you can summarize it very simple in it's a bunch of XML files in a zip file. So if you have a docx file, for example, or xlsx or pptx file, the easiest thing you can do is use 7-zip, right-click, extract to a folder, and you have the nice folder view of those XML files and structure there. It's a challenge, to be honest, if you look in what everything is meaning in these in the OOXML format. I went through like thousands of pages on the format, how everything is described, the different tags, the values, and it took quite some time to find the nuggets in there to use in the research. So, from an analyst perspective, it's very interesting to look at these following files. So, for example, the different content types, .xml files, it's actually describing the files in the package, the relationships of certain files, so the .rels XML files. Those are very interesting, which I will show you in a bit why. If you look, for example, at the word /settings.xml, so if you have extracted your docx file to a folder, you will see a folder called Word, and it contains the settings.xml. There are some of the interesting settings for the document over there. And also, if you look at the doc props and app.xml and core XML, it contains metadata that, for example, the creation date, the author, the template information, last modified, all those things are in those files. And besides the XML files, there's also some OLE objects or macros, of course, that are interesting, but also media. There's a folder called media if pictures are included. And researching those pictures, if they are cropped or contain metadata inside, are sometimes revealing really interesting bits that can actually help building your hypothesis around what happened and who is behind this. So I can talk a lot about this, of course, but why don't we take it to the next level and actually look at an operation where we did a lot of research on this. So recently in July, we revealed what we called Operation North Star, an operation where we saw job offers being done to people using Word documents, and then followed by some template injection, and that actually was downloading another dropper, and that was communicating with a command and control server. So probably spear phishing and some social network activity was used to distribute this campaign where they were targeting the defense companies around the world. So the interesting here was, first of all, the victim received a docx file. Very tempting. It contains some theme around the defense contracting companies, some nice pictures, the descriptions directly copied from websites from those contractors. So overall, it looked very tempted to click on. And the file itself was not malicious. The only thing what you would see is that it would contain in the relationships, like one of the things, a link to open a template file. So as you can see here, you see as like in site in Italy, and you see the 61.m in my top screen. And what actually happened is when you open up your docx file, underwater, it will download immediately this .m file and inject that template into your existing Word process, and then start to inject the DLL implant, because the .m file actually contains a Visual Basic macro and code to inject the DLL implant. So a very smart move, which we have been observing being used by this group in particular, Hidden Cobra, but we also saw this, the Gamma Reading group is also very famous for using this kind of template injection technique. So overall, over these months of campaigns, of the campaign, what did we collect actually? Well, we had multiple docx files with all kinds of job recruitment content. We had actually 2 PDF files. We had multiple of those template files, the dot files, and there was a bunch of there. And interesting enough was that all docx and the template files were containing the same language settings. So English, US, and Korean language settings. So, okay, fact noted, and let's continue and see what we can discover more. So one of the things that actually popped up was, when you look at the settings.xml file, there's this at the bottom, most of the time you see a value called W15. And I was really wondering, okay, what does W15 means? So again, I went through a lot of those documents from Microsoft about the standards, and I found some description around like W15, and it seems to be called the persistent document ID class. So it's a 128-bit GUID that's being set when you create a document. And the fact is actually, when you research more through documentation, and I verified with the Microsoft team as well, is that when a document is being saved as, it will copy the same value to the next document. So what does that mean for our research? So the interesting fact is then we had a ton of documents, as I said earlier. And when I listed all those document IDs in a list and actually put the creation date there, it means that the one with the earliest date with the unique ID must be the root document. So that's the document where the others are saved as from. So through the research, we saw with the different themes and file names and dates that, that we saw that same happening over and over again. So that was a really interesting fact to discover, that they were reusing a kind of root document and actually copy paste from that and save as well. Another thing that actually proved that hypothesis as well is that when you look in the settings.xml, you see sometimes this huge list starting with WRSIDs. It's called the revision identifier for style definition. So what it means actually here, when you compare, for example, document 1 and document 2, as you can see over here, the first couple of values are the same. So you see 0049, 0049D0C, and then the 6. And at some point, they start to differ. So it means they were using document 1 as a start, and then document 2, which had the same persistent document ID class value. They start to do some changes. And then it's actually where you see the changes where the numbers are differing here in the documents. So if you map that out, you get a really interesting picture when the templates or the documents are being changed and are being edited for a new purpose or a new campaign. And when you put it all together, as you can see here, this is very useful when you looking at a bigger campaign and try to spot some trends, and also timeline-based analysis to track the artifacts, what you want to do. And as you can see on the left side, I have here the file names, the creation date, okay, who created the document, what was the modification date, what is the modification user account. So as you see at my top, it's very interesting to see like a certain Xiong Yin Li is the creator of the document, uses a template here, but then robots Carl is actually the modifier and the revision numbers as well. And I had a list of more artifacts, of course, to this as well, but it really gave a nice insight, and it really helped building out the timeline combined with the macro code analysis with the backdoor analysis to really have a more in-depth case here where more and more I could actually tell about what was going on. And actually, this is all docx, and later, after we published the research, we found a doc file as well. And well, back to this research, which I already discussed, I could actually determine that the adversary as well was using a Windows 10 machine at some point to work on the documents and templates as well. And remember when we discussed about the print PDF or the print value, the print time value, exactly in one of the documents here, in the PDF document, I could say like, hey, this was print to PDF with a timestamp. And when we looked at the root document, we could actually see the match in the timeline, like, hey, when it was created, it really matched, the PDF matched with the print time of the words, the docx document. So overall, very interesting artifacts and very useful things you can actually use for your research. So if you look overall on the document analysis review, on this particular campaign, we saw same language settings. We saw a list of fonts that over and over were similar in all the documents. A lot of equal settings in the parameters. And if you look at that, I would say the top already, it could hunch to maybe a toolkit or a template kit they were using, but still, based on the artifacts I collected, I doubt if it was a real toolkit, because we saw a lot of modifications and manually being done, and then actually adjusted for the different campaigns. So it could be a toolkit, or there could be a root document which they used over and over again. We did timeline analysis on this. We saw a lot of similar structures in macros, in code similarities with previous campaigns. And we saw some of the templates being reused. And of course, many, many more, which you can read upon in our blog post. So with this, I really thank you for attending this presentation. I will be on the chat to answer some of your questions. And for that, thank you so much, and have a wonderful rest of your day.
Thank you. And Christian joins us live for a Q&A now. Hi, Christian. Welcome to VB2020.
Hello.
Hi. Do you mind me asking, where's Clippy? We were expecting Clippy to be with you.
I think he has a night off. I think he went out of town.
Is this because it's Friday night?
It's Friday night. It's party night.
I don't know, that Clippy. Yeah. Well, I think you can probably answer them maybe better without Clippy's help. There was a bit of interference going on there in the presentation. So it's good that we've just got you, Christian, really. Firstly, why are we having challenges with battling malicious Office files at all?
I think if you look back over the years, it's a kind of sinus wave of activity you're seeing around malicious documents being used. And we see over and over, because like if you look, for example, when you look at the Word documents and Excel document kind of information, it's like thousands of pages of information on how to write, or the stack, how it is working. So there's so much possibilities of actually putting code or other tricks into the Word and Office documents. So I think we're facing a lot of these challenges, and where we catch up on one technique, there's somebody else developing another technique. So that's why we have some challenges.
Thank you. Now, there's some interest in whether you needed any special tools for the investigation that you did. Personally, having seen your presentation, I'm wondering if your most special tool isn't just possibly the most amount of patience I've seen in anybody. I'm not sure that's what the question actually meant, but tell us, did you need any special tools for the investigation?
Patience is a good one, absolutely, especially when you do research. But yeah, I use some like kind of forensic tools to look at like FTK Imager, FTK, things like that. But also really like some of the open source tools I mentioned in my presentation to go through it. But I think there's definitely some need for, and it's a great audience here to call out, I think we need some more in-depth Office analysis tools, because I think the great ones, I think all the tools is perfect, but we might need some more to find more artifacts like I did today.
Okay, so that's on your wish list, at least, presumably a lot of other people's wish lists as well.
I strongly believe there's more to find in the document format, so yeah.
Excellent. You said when you were sort of talking about the distinguishing characteristics, one of the things that was that the same fonts were used over and over, and you saw the same fonts used over and over and over again. I just want to be clear that none of the fonts was actually Comic Sans, because that would make it very difficult to distinguish from a lot of, I wouldn't call them malicious documents, but just documents that people shouldn't be writing. But can you clarify?
Yeah, no, it's absolutely not Comic Sans, no.
Also, you mentioned 2 nation states in your examples in your presentation. Were there any cybercrime campaigns as well?
We look at cybercrime campaigns as well. They tend to use more kind of some of those tools that are out there to generate their documents. So I would say from a cybercrime perspective, it's more like they drop easily those documents like, hey, this is for one-time use, and then they get rid of it, and that's over. The fascinating part why I choose nation state is like I saw really trends around. They use over and over the same template, and giving that information and the information you can get deeper out of it, it helps you add pieces to the puzzle where you can actually draw some better conclusions to your competing hypotheses around the case.
Thank you very much. And thank you very much for joining us for the Q&A. I'm afraid we're out of time, not just for your slot, but for the whole conference. But thank you very much for joining us. I'm sorry Clippy couldn't join us on a Friday night, but I think we were better off with just you. So thanks very much, and hope to see you again.
Thank you very much. Bye-bye.
So there we go. That was our last live presenter quick Q&A on VB 2020. It's been absolutely fantastic. We have had 2,728 registrations. In terms of some updates, the mug. As I said, this is no longer my mug. I will wash it before we box it up and post it. That is now Veronica's mug, and Veronica has given us the princely sum of $155 to donate to the Land Trust to go towards environmental projects. So thank you very much indeed for that. You can call that your green mug now, even though it's blue and white. Very generous donation. Thank you very much indeed. The VB 2021 guessing has been continuing. In the background, there was a guess of Switzerland or Austria from Alistair due to all the bells that were going around. Leandro started guessing what looked like IP addresses for the next conference. And Liam wants a hybrid event. We shall have to put our thinking hats on for that one. Of course, next year's conference will really be well, I've got a few thank yous to do first. So firstly, thank you to all our amazing speakers, not just the ones that came on this live stream with us and chatted to us live in the Q&A, but also all the on-demand speakers as well. It doesn't mean you can stop watching now. Those are all still there. You can go and access those because you might not have seen all the ones you wanted to watch. So thank you to all the speakers for those. It's been a massive amount of work, not only preparing their talk as they always would, but this year they also had to film it and edit it if they wanted and send it to us. So we're very, very grateful for all the extra work you've put in, and you have excelled yourselves. Of course, we'd like to thank the partners of the event because they have made this thing possible, and they've made it possible for it to be free worldwide on the internet and available for anyone who wants it. Huge thanks to our awesome crew who have kept us going. Not only technically, it's been so smooth and well behaved as conferences online go. It's been excellent, but also in terms of smiles and laughs and quite a bit of extra filming. So thank you very much, guys, for that. I'd like to thank Karen for showing me how it's done. Newbie here. Had no idea what the whole bell thing was, and she set me straight on quite a few things, so that's good. I feel like I'm getting to know Virus Bulletin conferences now. And finally, a very big thank you to all of you for tuning in night and day, because there's the on-demand as well. For contributing in the chat, for keeping the jokes going, sending in your pictures, and making us all laugh, because conferences aren't just about content, although we've had some amazing content over the last 3 days. They're about what happened and the memories that you will take forward as well. And I hope you take forward good memories of VB 2020, and we hope to see you again next year in Prague. So well done to those of you who guessed Prague, and well done to those of you who saw the clues and the bottle of beer appear. We hope very much to see you in 2021 in Prague. So take care, and we shall see you then. Bye-bye.